Hello everyone, welcome to this brand new extensive session on Tableau. Today with this session we are going to touch upon almost all the intricacies of one of the famous data visualization tools named as Tableau. Basically, Tableau is an application that displays data in pictorial and graphical formats, which will allow you to gather insights from a huge pool of data. But before we take a deep dive into this software, I would suggest you guys to subscribe to the Intellipaat YouTube channel to come across more such technical updates. First of all, we shall look into the agenda for this session. We'll begin this session on a friendly note where we would introduce you all to data visualization and power of Tableau. Later, we'll talk about Tableau architecture. We'll show you how you can use this software to perform multiple tasks and how you can export your findings. Finally, we'll learn about how you can work with metadata and data blending. I hope I have made myself clear with the agenda. So without any ado, let's get started with this session.
So what we're going to do is there are various modules in Tableau which we're going to cover. We will start with the introduction to data visualization and why do we choose Tableau. Like there are a lot of visualization tools also available, but why is that actually that Tableau is much better in comparison with the other tools? And we will learn a bit about architecture. It just only like we will be understanding, but later we'll move into the further things like how do we publish it and so on in the later modules. And this module we will be covering how do we load our data into the Tableau application, like if at all we have to start working on the visualization, how do we load the data from there on, what is the understanding about the metadata and what kind of joins available and all. So I'm just giving a module agenda. So yeah, so to start with any answers for what is data visualization, what do you think of data visualization nowadays? Yeah, so graph, there is line graph is one way of representing a visualization, right? So like that we have many ways of actually representing the graphs. So that is called the visualization. So data visualization is the process of converting raw data. So what we call the raw data is basically the rows and columns. We have an Excel file or we have a CSV file or we have a databases where we have like rows and columns available. So this we call it as a raw data. And we can read this data at only like at 10 rows or 20 rows. But if at all we want to understand what is the meaningful information, so that's the way we will represent it in the visualization form. Yeah, so the visualization can be the charts, diagrams, pictures, etc. So if you see the right hand side, so whatever the data which is giving the information in this, the raw data, which we represented in the form of visual way. Like maybe the pie graph we are representing with the proportions, or a line graph to show the trends, or a bar graph to show the dimensions. So that is called the visualization. So which will help us in taking the effective decisions, and also it will help the organization to take the faster decisions. Some of the benefits of data visualization, it always allows us the users to get the different perspectives of the same data. So different perspectives means in this data, it may actually is, providing the information like a customer name, or in the healthcare section, if we talk about a patient information, the geography information, or, details about like, their ID cards, all these things. So if someone is actually looking this information in the way of like, they want to understand which geography this most of my actually customers are working in. So that one user is looking at the geography data. Another user wants to know what age group these customers are actually, buying from, my company. So another user is looking into the age group data. So like that, you can get the different perspectives of the same data. And also it makes it possible to interpret vast amounts of data. So while we do analysis in the Excel and other things, what happens is there is a limitation of how much data you can use it to prepare the graphs. But with the applications like nowadays, the visual applications, you can use large amounts of data to interpret and also to analyze. It offers the ability to note exceptions, like do we see any anomalies or do we see any outliers from the data? So this kind of information we can identify. Also allows the users to analyze visual patterns. Are we seeing any patterns out of this data? And also we can explore trends within the database. So this will allow analysts to navigate through data and visually orient themselves into the patterns of the data. So these are some of the benefits of data visualization. Apart from that, some of the applications are providing us, to do some, basic analytics. Like, we can do forecasting, simple forecasting. We can also do the clustering, and, we can identify the anomalies. So these kind of things also we can do a basic analytics in the visualization applications. So typically, what is visual analytics? It is a field, it focuses on the visualization, basically analytical reasoning, and that you put in the interactive visual interfaces. Yeah, so we can give filters. We can also allow them to give, to play around with the parameters. And the interactivity is something where, suppose if I choose a specific a region data, I should not be doing the separate region information for every, region. So if I change from the filter, if I give a north region, my report, my entire dashboard should display the north region data. So that is the interactivity. You are allowing the user to, they can actually, see their regions or the states, or further they can do the drill down options. So those are all the things which are possible with the visualization tools now. So also we can do some of the data analytics, like I said, a simple forecasting, clustering, and, all these things, the trend line charts. And we can also provide a kind of, anomalies and outliers. So that is also possible with the visualization applications. So we all know that, a picture is worth 1,000 words, because we easily grasp when you show a picture, or if you try to tell the attributes to visualize the picture. So it is easy always to see the picture and say, what is it? So that is the reason now the visualization is becoming more powerful in terms of actually providing the reports. Some of the business needs, yes, we provide more information in the form of now the graphs. So this more information than a table. A table can provide a limited rows or columns, but whereas actually visualization, there is no as such the limit. And that too in a much smaller place. Today, people can view their reports even in the mobiles or in the iPads, or in the desktops, anywhere. If they're actually, placed, they can view it. The data visualization helps us in better understanding. Also, we can take business decisions accurately and quickly. So this is what actually the people, they're focusing towards. And that's the way actually the developers, they are actually providing appealing and dynamic visuals, wherein they can manipulate and interact directly and easily with the data. Also, the most important thing is the reports needs to get automatically updated. We don't want to do manually every time, right? So the automation, and also it facilitates data analytics and data discovery, not only providing the reports. Like in analytics, we always speak about the descriptive analytics, diagnostic analytics, predictive and prescriptive. So we are not stopping at, the descriptive part. We're also moving towards the diagnostic and also the predictive part. So that will these reports will help you to facilitate data analytics and data discovery. We can identify trends and patterns so that the businesses can take the decisions immediately. So that's about the data visualization. So now coming to the real-time scenarios, for our practice, we're going to work on the retail supermarket data. So that I hope you all have the superstore data available, or download the sample superstore, an Excel file, which we're going to practice it for our, So yeah, so before that, actually, some of the real-time scenarios we can discuss. So this part is what we are showing is how the data visualization is helping the healthcare industry, in the healthcare industry, to be specific about the hospitals. So how the visualization is helping them is they are able to replace the manual reporting efforts, and also provided the real-time insight into the acute hospital services. So what are the services they're providing? How does it actually, how they improve it? And also they can uncover the hospital patterns and trends. So if we go to this particular visualization, the first one, which is breach status by hour of arrival. So this is for a hospital, which they're actually tracking the information. So this is this part, right? Morning 10 o'clock to evening 6 o'clock. So this is the time actually the breach happens more, because they are not within the compliance. So their compliance is, this report tells me the information. The number is representing the number of records. So this means like a number of patients who are walking in. In that, they have a timeline like within less than 4 hours, everybody has to be attended. Whether the treatment information, we don't know, but they should be attended within the 4 hours. And we see there is a red color representing over 4 hours. So this means there is this part is not compliant. And we also see some information which is unknown, which is in the green color. So by seeing this report, now I can come back with some information or insights. I can say that, yeah, 10 o'clock to 6 o'clock is the busy hour. So this means more patients are walking in and we have the less manpower. That could be one reason. So maybe when I have to get into the detailing of this one, 4 or 2, these numbers, when I start drilling down, so what is the issue? I can identify. And there is also green color. When I see the green color, so this means unknown means either at this time from evening 7 p.m. to the 11 p.m., the data is not properly getting captured. This could be the reason. Maybe the people are not trained enough, the manpower is not trained enough to update the information, or we don't know, like, what is happening here. So that could be another insight information. So now by seeing this breach status, now if at all I need to fulfill the manpower between 10 a.m. to 6 p.m., I have another chart which shows that there is a pie graph wherein the specialty weight breaches information available for that particular hospital. So they deal with 50% of the time with the stroke related issues. So this means when I'm filling between 10 to 6 p.m., I need to be mindful when I'm looking at this part, how much manpower I need to bring in for this particular specialty weight breach or urology or pediatrics or general surgery. So this is the next level of drilling down. And then we'll move to the LOS, which is the length of the stay. So like patients are staying in the hospital, how long they're staying in. So with that, I can predict when is the next bed available for the patient who are going to walk in, the next one. So this is what actually we can get into further more drill down by seeing the raw data, and we can develop the reports. So that's the way basically the issue will be always. The challenge is how to get insights and actions from the information. So we can use any of the applications, that visualization applications, to empower in the organizations to create the reports, and then that will help them to find the right path forward. So some of the KPIs, like the key performance index, people can actually look into it is they can identify which are the areas where they can reduce the cost, how to improve the quality, and also how to improve the patient experience. So this will help them in getting the business in more detailing. So that's about a real-time scenario. How can we go through into the more of detailing reports? Yeah. Now we move on to the introduction to the Tableau. So why is it Tableau? Why we are choosing Tableau always? So Tableau is an interactive BI software used for data visualization and analytics. Yeah. So this is founded in January 2003 by Chris and the team. They developed this software. So Tableau is basically to analyze and transform data into interactive visualization. So interactivity is nothing but you can give the filters, parameters, all those things. Also, we can query a range of data, including relational databases, OLAP cubes, cloud databases, and spreadsheets to generate number of graph types. So this means I can connect to any type of databases or any type of data sets to create my reports. So the power of Tableau, this is the most important thing. This is easy to learn. Compared to other visualization tools, Tableau is the easiest one to learn. And also it is easy to use tool. The reason behind this because it has a drag and drop. I don't need to write the coding, or I don't need to create the queries to actually create my reports. It is drag and drop technology. It is a user-friendly interface that helps generate visual reports in easy to understand formats. So this encourages even business users also, they can create on their own. Maybe they cannot get into more detailed advanced reports, but yes, basic reports, all these things they can prepare on their own because it has a drag and drop technology. Now Tableau stores data in memory. So what happens is whenever we connect to our databases, it is not advisable every time to go with the live connection. So in Tableau, there are two types of connections. One is live and extract. We'll go into the detail, that one. So most of the time, if your data is not really required in the real time, it is always suggestible to go with the extract mode. So when you do the extract, so what happens is the data stores in memory, which is also called RAM or flash memory, so that the processing speed is much faster. While whenever you open the Tableau workbook and then you refresh it, it is much faster, the processing speed. So that is the reason it is called RAM or flash memory. So today, many organizations are using the Tableau in the office and on the go. And in Tableau, there are various products available. So one is the Tableau Desktop, which you all downloaded. So this is a licensed version, wherein most of, all the organizations, they use a Tableau Desktop. There is also called another product, which is called Tableau Public. Tableau Public is free. It is not a licensed one, but it is a free, lifetime free available. If you want to practice it, or if you're a student or you're using for your personal purpose. So those things, if you want to use it, you can use a Tableau Public. All the features are same, except there are 3 features which I will explain the coming sessions. But rest, all the features are same. If you want to practice it, or if you want to connect with the community, Tableau community, and want to learn more, then you can actually use a Tableau Public and go ahead. But the desktop is a licensed version. After the 14 days trial, there is a license. We need to actually purchase the license and then use it, because Tableau Desktop is a safe and secured one for your data. Whereas a public, the name itself is a public. So whatever you create the reports, you need to publish it in the cloud, which is visible to everybody. So that is the reason we normally organizations, they go ahead only with the Tableau Desktop. Now, Tableau visualizations are automatically streamlined for mobile devices. Like I discussed, you can actually represent it in iPads, Android tablets, or even in your mobiles also. So where the views are different, while you are publishing it, you will synchronize accordingly for your tablets or for the mobiles. So that's enabling mobility so that the data and reports can be accessed from anywhere at any time. So this is the power of Tableau. So what all we can do with it, integrate with the, some of the data science tools, like, you have R and Python, you can integrate it. It's easy to learn and it is mobile based. Like, you can publish it even in the mobiles also. And this is the comparison with the other vendors, Tableau versus other visualization vendors. Yeah, clearly Tableau is in the leader section. This is a Gartner Magic Quadrant. So it's a Tableau is in the leader section along with the Power BI and the Click, and the rest all are in the niche or in the visionaries. Now coming to the Tableau products, like I said, we have various Tableau products available. One is the desktop. That is what we downloaded, the 14 days trial version. Another one is a Tableau Public, which is a free licensed based. And we have Tableau Server. In Tableau Server, there are 2 types of servers. One is the on-premise and another one is cloud-based. So on-premise is called Tableau Server, and then the cloud is called Tableau Online. There is another one called Tableau Reader. So this is also a free one. I will explain. Here you cannot develop. It's just that you can only view the reports. That is a Tableau Reader. And the last one is a Tableau Prep. So this is the ETL tool. This is recently launched by Tableau company 2020. Earlier, there was no ETL tool available for Tableau. They recently launched the Tableau Prep. This is called Tableau Prep ETL tool. So the Tableau Desktop, this is for the creation. So the creation is, we can create ad hoc analytics. We can create dashboards, reports, and the graphs. Also, we can do the exploration, visualization, and analysis of our data. And we create the dashboards. Once the reports are ready, then we'll move to the dashboards. And you can create the dashboards to consolidate multiple views. That is nothing but your reports. So you also can deliver the interactive data experiences. So we can provide user-enabled interaction so that people can also use the interactivity. Now the Tableau Public also does the same thing. All the things which desktop is doing it, the Tableau Public also does the same thing. It's just that it is a free download and free hosting service. So your data is not secured. In the Tableau desktop, it is secured because it is a license based. Public, it is not secure. And also you cannot connect to any of the databases. You can just only connect to the file types in the public. So that is one first difference between the public and the desktop. Now the Tableau reader, once you create the reports in the desktop, what we do is we save the file, we save the workbook with the extension called TWBX, which is called Tableau Workbook. Once you save the file, if you want to send it to the another user or someone has the, the reader application is there in their system, if you send the file, they can open the file in the reader. So this reader, people cannot actually create any reports. They can just view the reports. So that is like whatever the report is, the workbook is shared, they can open the workbook, they can see the report, and they can just do the filtering. That is a little interactivity is provided to them. So they can do the filters or sorting, or they can see the page through views. That's all. They cannot create any reports. They cannot create any dashboards in the Tableau reader. And they can do the PDF. You can convert into the PDF. Also, this is a free download. So this is not licensed. This is a free download available. So basically the end user, if the end user wants to see the reports, they can download the Tableau reader. Now, coming to the servers, once we create the reports, we need a place to publish it. See, whatever we are doing it in our local systems. In our laptops or in our desktops, we are creating the Tableau reports. Once it is ready, you need to publish it somewhere for the people to view. So that place is called Tableau server. Like I said, Tableau server is two types. One is the on-premise server and another one is a cloud. Both are same, except that, so cloud-based deployments is managed by Tableau, whereas on-premise is managed by your own company. But both are safe, secure, and everything is taken care. And you can collaborate with others in the Tableau server, like a developer like you and me. Suppose if I'm working on the same workbook, we can collaborate and we can work together in the Tableau server once it is published. So that's about the servers, online and the Tableau server. The last one is a Tableau prep tool, where you can do before actually connecting your data to the Tableau desktop directly. You can do all your ETL activities in the Tableau prep tool. So this is a different application altogether, wherein it is also a license based one. You can perform all the cleansing activities or joins or whatever you want to do it. You can do it in the ETL tool, and then you can bring it directly into the Tableau desktop. Of course, without this also you can do, but there is a limitation in the Tableau desktop. Like, the large data sets, you cannot do all the ETL activities. Maybe, once it is, your, ETL is completed, that output file, you can bring it into the Tableau desktop. So that is the difference between all the products. So the similar products are Tableau desktop and Tableau public, Tableau server and the Tableau online, and these two are the different ones. Okay, so how does the Tableau work? Tableau works with the three simple concepts. One, you connect your data. You can connect to any type of data sources you want to analyze. After that, we start doing the analysis. Analysis is like, you load the data, start creating your reports, and then prepare your dashboards and, perform some of the filters, aggregation, sorting, all this manipulation you can do. And then you share the results. Once your analysis is ready, we share it with the users, end users, through the workbooks, so that people can view it in the reader, or you can publish it in the server. People, the end users will be given access to log into their IDs and they can actually view the reports in the web. We can also do some of the things like, you can convert it to the PDF, you can mail it to your, the end users, and then you publish it in the servers. That's about, connect, analyze, and share. So we'll move on to connecting to the data. So this is what actually the Tableau looks like. When you download the application, when you open it, so right-hand side, you're seeing, right, there is a connect, open, discover. The page looks like this. So the step one is click on the Tableau icon on your desktop, and then you open it. While you open, the second step is there is a connect space available. Okay, so let me show my screen. Okay. So this is the Tableau. When you open, so this is called the icon of your Tableau icon. When you click, the new workbook will open. So this space is called a connect space. If you want to pull in your data, you can go directly to the Tableau server and from there you can get your data, or you have a file types available. All these file types you can bring the data. It can be Excel file, text file, JSON, Access, PDF. Spatial files are something for the geocoding and all, statistical files. And we have the server types. So any type of server, if you click on the more, if your organization is using any specific databases, you can connect to any type of servers. Yeah, some of the servers you can connect directly. Like for example, if I click on MySQL, you can go ahead and connect your MySQL by giving your username and servers and all. If you're connecting to the Hadoop, Cloudera and all these things, what happens is you need to download the ODBC drivers. So you can, if your organization permits, or you can ask your IT team, they can download. The help of them, you can download the drivers and you can connect to your servers. We will get into this one more detailing later part. As of now, we will get into the Excel. And also we have this space called save data sources. So if any data sources are available, that you can use it directly by clicking on these things. This part is for that. And we have some of the reports which you already prepared, the workbooks already there. That will be for this section. You can open your existing ones and you can, if you want to use it, you can click on any of these things. On the right hand side, there is an option called Discover. These are the videos directly from the Tableau company. So at any point of the time, because a Tableau always comes with the latest updates, version updates. At any point of the time, if you want to understand the detailing part, you can go ahead and click on these videos. So these are all also helpful. Like, we can improve our, the versions and all these things by connecting to these videos. And these are the resources available. There is a community forum where you can connect with the other Tableau developers from any, all over the world. You can post your questions. Sometimes if you're stuck with any of the development and all these things, this community forum is really, really helpful. You will get the answers immediately. And they also will help you with, kind of Tableau workbooks so that you can just go through the steps and, you can learn. So I suggest, this is really good. And any latest updates you can see here. So right now there is a 2021.4. This is the latest version available. You can download and you can update it. Apart from that, there is a Tableau public gallery available. Okay, so this is called Tableau Visualization Gallery. The one which I was talking about, the developers, people who are actually working on the Tableau public, they publish it here. So suppose if you have a Tableau public account, you can sign up, you can create your own Tableau public account. Now the data sets, open data sets are available where for your practice, you can connect to any of the data sets, Excel or CSV files, you can create your reports and publish it. So for example, if you want to discover anything, so this is called visualization of the day. There are various industry related reports are available like sports and fitness or something like healthcare industry, education, arts and culture, anything like, you can go ahead and get ideas from here. For example, if you see something interesting here, maybe Team USA at the summer games. For example, if you click this one, if you want to understand how this particular visualization is prepared, few of the developers, they do provide even the Tableau workbook download option. You can go ahead and click here. So this is the download option. You can download it. So yeah, so this person, he has given the option for us to download the workbook. You can download the workbook and get into the detailing of how this report, this particular dashboard is prepared. So though this is already an interactivity one, but still you can go ahead and actually check. If I click on any specific team, I can see the information. For example, if I'm going ahead and clicking on the women team, this report is for them. So this is interactive already given. How this is prepared, you can actually go ahead and download it and view the report. I'm just giving download, later part I can show. So like that, you have a lot of industry reports available if at all you want to go through, or if you want to contribute. Open data sets like you have population information, census information available, WHO data sets available, all these things are there. Anybody wants to try, you can go ahead and do. This is really good practice. Yeah, so this is what actually the report was prepared. If we go and open it, how each report is prepared, you can see. And this is actually made it into the dashboarding part. So this is an example. Okay, now let's go back to our. Okay, so now I gave the Excel file. So what I'm doing is, can you please all open the Tableau? So once you open, are you all seeing this page? So now what you do is click on this option called Excel. If it is a text file, I will choose the text or whatever the file type, accordingly we choose. Now, Superstore data is Excel file. So I'm clicking on the Microsoft Excel. Now this is Excel file. So go and locate wherever you saved the file and then select the file. I'm selecting this one and clicking open. So this is the option open. You can click on the open. I'm just waiting here so that you all can see. So when you click on open, you all will see a data source page. On the status bar, you're seeing there is a data source. So this page is called data source. Here is the place we connect our data sources. Now the Excel file has 3 sheets. So that is why it is representing sheets. 3 sheets, one is orders, people, and the returns. There are 3 sheets available. So you can see each sheet here. In this, this place is called for the connections. Suppose this one, I connected only one file. For example, if I want to connect another file, again, I'll do here, click add. You will connect to again either a file or a server, you can connect it. Like that, you can do a multiple data connections. You can go ahead and keep on connecting. How many tables you want, you can go ahead and connect. So this space is for the connections. Like I said, it is a drag and drop technology. You don't need to write anything. Just drag this orders table here. Drag tables here it is showing, right? Just leave it. Drag and drop. I'm showing it again. Just drag the orders table here like this. Okay, so this is orders table. Just drag like this. Drag it and leave it here. So if you all see, there is only 3 sheets are available. Here, assuming these sheets are called tables. So now what I'm doing is I just dragged in only one table, that is one sheet only. The moment I drag it here, you are seeing this space called connections, which is called a live connection and an extract connection. Because we connected our data by default, everything will be a live connection. We will convert later into the extract. But as of now, you all see with the live connection. Now the difference between the Tableau Public and the Tableau Desktop, Public will have only the live connection. Whereas the desktop, the licensed one, you have extract option also available. So this is called live and extract. Now, on the right-hand side corner, you're seeing filters. So these filters are called data source filters, which we will learn it while we are learning the filters part. So this space is for the filters. Now, I'm just little moving up this one. So this is the data preview. This table is the orders table. Total what it is showing is there are 21 fields available. So all these things are called 21 fields. This is your metadata information. And the rows are 9,994 rows. So our data set is 9,994 rows available. So let's go back to this one. After loading, we see there are data types. In Tableau, there are 6 types of data types available. And every data type will come with a icon representation. So you can easily identify when there is a ABC on the column. We know this field is called text values. The date values will represent with the calendar. Date and time, it will come with a calendar and a timer. Numerical values are represented with the hash. Boolean values are true and false. The geographic values, which you can use it, this particular field for your maps, that comes with a globe icon. Now let's go back and see our Tableau. You're seeing the data types here, hash, ABC, calendar. Here also you can see the data types. So now it is easy to identify when we are in doubt. We don't know whether it is a numerical column or I'm just saying, or a string. You can easily identify by looking at the type. I'm repeating, in Tableau there are only 6 data types. So those 6 data types are what? Hash, ABC string, date, that is a calendar with a timer, Boolean values, true and false, and the globe. So this is, you can use it with the maps. Now, after the data types, we will learn about the field types. There are 2 types of fields. One is called a dimension, another one is called a measure. So when we connect our data, Tableau assigns every field to either a dimension or a measure. That is depending on the type of data of the field contains. If a field contains categorical data, so this means names, dates, geography, all this information, it will assign to the dimensions area here. If a field contains numbers, it will go to the measures area, this place. So now from our data, if we see the data types, ABC, this is called a dimension because ABC is a customer ID, customer name. Why customer ID? Because it is alphanumerical number. So that is the reason it is the string. And segment, this is also ABC. So this is automatically a categorical variable. Region, product ID, category. So now even the country, city, state also, this is also the names, right? So that is the reason they're also, though they represent geography, but these are all dimensions only. It is easy to identify. Measures are with the hash. So this means where you can perform the aggregations. So those are all called measures. So we have 4 fields: measure, sales, quantity, discount, and profit. So these are measures and rest all are called dimensions. Yeah, so date can be used as a dimension and a measure. We will learn how to use it. So, but date by default, it is a dimension. Now going back to this one. So in Tableau, there are 2 types of fields. One is a dimension, one is a measure. Dimensions, as a thumb rule, they're called discrete values, wherein you can do the drill down. Measures are, you can perform the aggregations. That is why it is called continuous values. So when someone asks you, like, you always, in the field types, dimensions are discrete and measures are continuous. However, you can also use your dimensions as your continuous values, measures as your discrete values, as and when required. Yeah, that it can be given phone number, where we can give the count of how many phone numbers are available in the data. Apart from that, there is a major one that is called age, right? So there is a age is a factor. It's by default, it is a numerical value. But what happens is, if I want to understand how many customers are in the age of 18 years, 19 years, 20 years, at that time, what I use is, I convert my measure into the dimension to get a information of the count. So that is called your measure into the dimension. You can use it. Sometimes you have a discount. Discount is basically your measure that I want to see as a dimension. Like 10% discount, how many customers are there? 20% discount, how many customers are there? At that time, I'm using my discount as my dimension. So in Tableau, by default, dimensions are discrete and measures are continuous. However, all 4 combinations are possible as and when it is required to change. Now, how do I identify the dimensions and measures? Because it is sometimes it is a little complex. How do I know which is a dimension and a measure? In Tableau, it is easy to identify. Dimensions are always comes with the background color blue. Measures are always with the green color. Now, if we go here into the sheet one, when you click on the sheet one, if you hover around on this fields, it's all in the blue color. So this means these are all dimensions. When I go here and hover around, it is called green color. It is showing green color. So this means these are all measures. So when in doubt, just go ahead with the color coding. Dimensions are blue and measures are green. So if you are dragging a field from the dimensions area, the resulting field in the view will be discrete with a blue background. If you are dragging a field from the measures area, the resulting field will be continuous with a green background. So now I'll just go here and drag it. Suppose if I'm dragging the category, even here also you can see this is in the blue color. So this is called a dimension. And I go ahead and click on the sales and drag it onto the columns. So now this is in the green color. So this is called a measure. So you have a dimension, you have a measure. I created a report, a simple report. So blue and green. So that's about the field types. So we have learned data types, which are 6. We learned the field types, those are all 2. Further, you can actually go ahead with the discrete and continuous for each type.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
So now we will move on to the file types. We have seen the data types and field types. Now we'll move to the next one that is called file types. In Tableau, there are 6 types of file types available. We have a TW. Every file is with extension T, that is a Tableau. So there is a Tableau workbook, Tableau packaged workbook. We have a Tableau bookmark, hyperfile, TDS, and TDSX. So now when we save the file with .twb extension, so this means the file will save with worksheets, dashboards, and the stories. That is, when you complete this, for example, a workbook, you opened it, you completed a report preparation and all. Now you want to save the file. What you will do is file, click on the save as. When you click on the save as, you have a file type called TWB. You give the file name and save it as a TWB file. When you save it, what happens is it will not save the data source. This part will not be saved with your data. It will be saved only with your sheets. This is called a dashboard. Dashboard looks like this. And this is a story. This looks like this. So you have a worksheet, you have a dashboard, you have a story. So whatever you prepare in these 3 types, it will save. That is called TWB. Save as TWB. If you want even the data source also, so this means if you want even this part also to be shown, then what you have to do is file, save as TWBX. So this is called Tableau packaged workbook. You can save it as a TWB or a TWBX. TWB will not be with the data source. TWBX is with the data source also. That's the difference. Now, when you save the data source, TWBX file, it is called a zip file, it will save. So it will come as an archive containing a workbook along with all the data sources and the files. So it's a zip file, you can send it. Now we have a TBM is also available. TBM is called Tableau bookmark. So this Tableau bookmark contains only a single sheet. That is only one report. Bookmark means only one report can be saved. If suppose you have various reports available like this. For example, in this, I created another report that is a region report, region sales report. I've created another report that is a state report or something, or a ship mode, another report. So I do have a sheet 1, sheet 2, sheet 3. Tableau bookmark, when I select one report and go ahead and go to the window menu and click on the bookmark. When I click on the create bookmark, it will save only this report only. It will not save data source, it will not save dashboard, any other reports are there in this workbook, it will not save. It will save only one report, that is called this one, sheet 1. That is called Tableau bookmark. So this means a single report. If you want to share with somebody, you can use this. Now we have another one called Tableau data extract. This is also called as a hyperfile. Normally the file extension is TDE, Tableau data extract, TDE file, which is nowadays it is called hyperfile. So what does this mean? It is the local copy of a subset or the entire data source to share and improve the performance. That is, when you go to the data source here live and extract is there, right? Go ahead and click on the extract. When you click on the extract, when you click on the radio button extract, then click on any one sheet like this. It will prompt you to save. Can you see this one? This is called Tableau data extract and a hyperfile. So what it will do is it will save only the data part, this data, whatever you have. Whatever you have connected here, that will save a local copy in your system, so that it is easy to load the data and work on your reports faster. Or when you don't have an internet connection, at that time, what you can do is you can directly load your Tableau extracted file and you can work on your reports. Or if you're sitting at a remote location, still you want to work on your reports, you can use a Tableau data extract. So this is called a TDE file, also called as a hyperfile. How to do it? Just go to the data source. It is a live button. Click on the extract, and then you click on any sheet. It will prompt you to save. It will come as a file type, TDE file. Now, if you created this report as a visualization, this will not save in the TDE file. It just that only the data will be saved. That is the difference between the TWB and the TDE file. The last two are called TDS and TDSX, which is also called Tableau data source and the packaged data source. What is a Tableau data source? Tableau data source will give you the shortcut to frequently used data sources containing information and modifications. For example, which data source you connected, that information it will provide. Also, any modifications or refreshers you have done. So that information available when you save the file with the TDS. Whereas with the TDSX file, along with this information, it will also save the data source files too. So this means you can have an archive of the data part too. That is, you go here, go to the sheet, and then data is there here in the data. When you go to your data source, so that is called order sample superstore. Go to data, order sample superstore. Here, you can actually give it as add to save data sources. This option. When you click on this one, you have a TDS and TDSX file types. So these are the two types. Now, most of the time what we use is we use the TWB and the TWBX. So that is your workbook. You will save the workbook and then you'll publish it. Publishing it directly in the servers we do. So that is the reason we save it as either TWB or TWBX most of the time. I can say 90% of the time we use only these two. That's about the file types. So now, like, remember, how we can remember is data types are 6, field types are 2, and file types are 6. That's the way we remember. And we also have some information about what is the difference between TWB, TWBX. Basically, TWBX is a packaged workbook. It will come with a zip file. This will be helpful while we don't have the internet connection or the network connection. You can use the TWBX file and work on it. That is the major difference. Okay, so we will move on to the architecture. So this is all like, your trial version, whatever you have downloaded. It is just the steps for the reference. Okay, so the Tableau architecture has a highly scalable entire client server architecture that serves mobile clients, web clients, and the desktop installed software. So this is the place where we are working right now. Tableau Desktop. In our laptops or in the desktops, we are creating the reports. Once our reports are ready, so the Tableau Desktop is the authoring and publishing tool that is used to create shared views on the server. Once we are ready with that, we publish it in the Tableau server. It can be online or it can be an on-premise server. Once it is published, then the users can view it in the iPads or mobile safaris or the Androids or the PC browsers. So this is the views. Now you can see your data server, you load your data, and then using the data connectors, your data is connected. And then the components we have is application, Visual SQL Server, and the data server. This is the gateway load balancer. From the gateway, so that is your authoring tool, people can view it in their desktops or mobiles or the webs. This is the architecture. Okay, so the Tableau server architecture scales up is multi-threaded and scales out is multi-process enabled. It can provide integrated clustering and it supports high availability and your data is always secure. It can run on both physical and virtual machines. That's about the architecture. But we will learn how do we publish it in the server, and from there, how do we assign the users, what kind of user access we can provide. Those things will come under part of architecture in the last modules. Okay, so how do we start the Tableau? We already learned how do we actually connect our data. Yes, this is the first visualization. We'll go back to this. I'm simply repeating it again here. Once your data source is connected, here, drag it. Table 1, you dragged. And then now go to the sheet 1 here, click on the sheet 1. So this place is for your fields. You have the dimensions, we also have the measures. Now, this is the place for the design of your visualization, this white space. Now you can bring the dimensions or measures anywhere, either in the columns or in the rows. There is no restriction that you have to bring the dimensions on the rows and measures on the columns. You can use it vice versa, anywhere. So I'm just dragging the subcategory onto the columns now and the sales onto the rows. So by default, a simple bar graph is created. So this is your first report. Now, how do we work? What is that actually metadata? And there are various types of joins, blending, and relationships are there. Let's get into that. We will learn the metadata first. Okay, so when you connect your data, we know the field types are available here, correct? Sometimes what I want to do is, I want to split the column, that is split the field. For example, order ID is there. This is alphanumeric. I see there is a country information. This is CA is Canada and US is United States. After that, there is a number that is called a year, 2013, 2011, 12. This is called your year data. And there is an invoice number. This is order ID, right? So there is an invoice number available, 152156. So what happened here it is, this is concatenated. So that is why you're seeing it in one particular field. Now I want to actually split this one into various fields. So how do I do that? Go to this drop down or go to the field here, order date, or sorry, order ID. Click on this drop down. There is an option called split and custom split available. Split is by default, Tableau will give you the best option, seeing the field and it will give you the split. There is a custom split where you can decide how many fields you want to separate it. This means how many columns you want to split it. So let's do the first one, that is the Tableau decided one. When you click on this split, automatically this one is done. So where we see there is a scroll bar is there, just move towards to the right. You can see order ID 1, 2, 3. So it divided into 3 columns. The most important thing you have to remember is that Tableau will never touch the original fields. So this is the original field. It will not actually replace it. It will create a new field. So now you can see 1, 2, and 3. So earlier we have seen order ID as the alphanumeric, that is a string field, right? Now what happened was the moment it is done the split, now this is a text value, this is the measure. It is automatically, because there is a numerical values hash symbol is there. So it is giving, it is assigning the data type as numerical number, these two. First one is anyways, we know that it is a text value, that is why it is string ABC. So this is the Tableau divided split option. Now, you all can ask me why this one is showing with the equal to symbol. The rest of the fields, it does not have the equal to symbol. And you all can see there is a blue color line is showing here. But the one which we have done the split just now, you're not able to see the blue color line, and also you're seeing the equal to symbol before the data type. The reason is it is easy to identify in Tableau. Whenever you see there is a equal to symbol before your data type, this means this is user defined field. This means you and me, we actually created the field. It is not coming from your tables. So that is the difference between equal to symbol before the data type. Okay, so this is the order ID column. I want to separate it because I can see there is a numerical value. There is also a string value. So what I'll do is I'll go on the drop down here, or go to here metadata and click on the drop down. Anywhere is okay. Go to that field, click on the split. When you click on the split, Tableau will decide the best split option for this column. Now the split is done. You can see the same order ID is divided into 3 fields. Order ID 1, order ID 2, order ID 3, split 1, split 2, split 3. Now the difference between user ID column or the table columns is the equal to symbol. Just go through all these numbers like ABC, there is no equal to. Date, there is no equal to. Date, there is no equal. So you are not seeing any icon before the data type equal to symbol, because these are all called your directly coming from your data source. Whereas the split one which we have done just now, it is showing equal to symbol before the data type. This means this is a user defined field. We have created this one. It is not coming from your data source. Yeah, and also another way of identifying is there is no color here. So that is also the another way of identifying. Now this is the split by default Tableau has done. Now I want to create a custom split. Go ahead here. Again, go to the order ID. Click on the custom split. Now this custom split, you can decide what you want to do. You can see the separator is hyphen. So you will give hyphen here. Now, how many columns I want to split? Do I want only the first column, that is the CA, or I want only the last column, that is the last invoice number, or I want the first two, or the first three, last two, last three? You have options, or all. You can choose. Sometimes there is an address in one column, the entire address will be there. I don't want to actually, divide that entire address into various columns. I want only the last column so that I can see the city name or a state name. At that time, what you will do, last one column only, or first one column only. I want only the house number. So I'll give it as first one column. So this you can decide, custom split. Now, for example, if I give split of first one column, click OK. Now it is giving only one column split. Okay, so this I previously done, so I'm deleting it off for your reference. Only one column split it has given, and that to first column only. Now, and if anybody wants to try and delete the data table columns, it is not possible. See, I don't have an option called delete here. I cannot delete any of these columns because they are coming directly from your table. I cannot delete any of the columns. Whereas the one which I created, that is we created user fields, that you can delete. See, you have an option called delete now. Whereas here, discount does not have the delete option. I can go ahead and delete this. But these columns I can never delete. Now the next option, we have a rename. I want to rename the field. Click on the rename. I want to change this order ID to the order ID 1. I can change it. So here it is changing. But whereas if you see the remote field name, that will not change. Only for your Tableau, this particular workbook, the field name will change. Order ID 1. If you want to reset back, just click on the drop down again, reset name. It will go back to the original name. So that is the rename option. You can copy values. When you copy the values, suppose if I'm clicking the copy values and go to an Excel file. So when you paste it, it will give you the metadata field names. See, this is my metadata field names. Field name, physical table, and remote field name. So you can use the copy values for the metadata fields. Now, like I said, I cannot delete the fields. These are all from the data tables, right? So I cannot delete the fields, but I can hide the fields. Suppose I don't want these columns. For example, order date I don't want. I can go click on the drop down, hide it. Now it is hidden. I will go to the customer ID. I don't want customer ID. I'll just hide it. So when you go to the sheet 1 here, you cannot see the customer ID or you cannot see the date, which are all hidden now. Those two columns are hidden. But if you still want to see what are those hidden columns, click on this drop down. Sorry, 1 second. Sorry, click on this part, this settings part. Here, the small icon is there, right? Settings part. Click the show hidden fields. Now you can see the hidden fields in a light color, faded color. So this means these also fields are available, but right now these are all hidden, which I cannot use it in my reports. Now you can go back and see in the sheet 1, customer ID is available. But if I want to bring drag and drop, it will not work because it is hidden. I cannot drag the order ID. Whereas I can bring the category, which is because this is not hidden, right? I can bring the category, but I cannot bring the customer ID or the order date. I gave the option as a hide. Now go back here, again select it and then unhide. Now it will work. Now go to the sheet 2 Now order date is working. Here order date is working. Still, I am not unhid in this one, customer ID, I cannot work. That is the difference between hide and unhide options. So the one which I was talking about is this product ID is there. You can do the custom split. When you do the split, here you have 2 text columns and 1 numerical one. Earlier in the order ID, 1 text column and 2 numerical values, whereas for the product ID, you will get now 2 text values and 1 numerical value. So this you can try it out. And we have another option that is order ID, right? Yeah, we have seen the rename, copy values we saw, hide and unhide we learned. There is an option called alias is available. So what this will do is, let me go to the segment here now. I want to actually change the field. This is the item. There's the members in that particular segment. In the segment, there are 3 types of segments are there. One is a consumer, corporate, and home office. So for example, if I want to change the consumer to consumer one, I can give the alias name, corporate to corporate one, home office to home office one. And click OK. So what happens is now your data will be changed into the consumer one, corporate one. So I've renamed the data items in that particular field. Home office one, consumer one, and the corporate one. If you don't want, you just go again to the segment, aliases you click, and clear aliases, and it will take back to the original ones. Now it is back to consumer to consumer, corporate to corporate, home office to home office. Like that, even in the field also, in that particular column, you can also change the member names using the alias option. So that option we have. So we covered alias and then split and custom split. We will learn about calculations and grouping in the module 2. So we'll not touch this one right now. We have a last option called describe. Suppose when you don't know what is this field all about, you can just simply click the describe. It will tell you about that particular field. So the segment field is a discrete dimension. Yeah, it is a dimension. It is a discrete value. It is called a database column. From where this is coming in, it is coming from the orders table. And the field name is segment. The remote type is a character string. Does this field has null values? No. If there are null values, it will show as a null values. It's in India English because I'm logging in from India. If you are from the US, you can see that as a US English. Sort flags, it is case insensitive. So you don't need to worry on the sensitivity of the case. It is case insensitive. The column width is 11. Status is valid. And what are those members available in that particular column? There is a consumer, corporate, home office. That information. You can close. Or you go to the customer name and understand what is this. Describe. Now you see in the customer name, it shows that there are 793 customers are there in the entire data. Out of that, it is showing a sample of 20 here. Total 793 customers. Now we have seen everything as a discrete values dimension. Let's see the measure field. I'll go to the sales, click on the drop down and then describe. Now sales is called a continuous measure. It has a database column. Remote column is the sales. And this is a double precision floating point number because you have decimals also in this. By default in Tableau, always there is an aggregation that is a sum. So that is why default aggregation is sum. The domain for this field has not been loaded. I can click on the load so that it will give you what is the minimum value, what is the maximum value for this particular column. The min value is 0.442, max value is 22K. That's what it is showing. So the values are in between 0.44 to 22K. That's about the measure field. You can see the same thing for profit. Describe. Your profit value starts with negative 6K to positive 8K. Between those values are there. So this is to understand what is this field all about. Whenever you have doubts, you can just go ahead and click on that particular field and then click on the describe option. You will get the information. So this is called your metadata management. So far we have learned the field types, data types, file types, and then the metadata. Now the next one we'll move on to that is how do I join? There is one table we brought in. If I have multiple tables, how do I join those multiple tables to bring in a view? That we will learn now. Just a moment. So connecting to the multiple data sources. You can connect to the multiple data sources in three ways. One is called data join. Another mode of doing is data blending. Third option is called relationships in Tableau. So the three ways of doing it, one is a joins, one is a blending, one is a relationship. So when do we use the data joins? When the source data tables reside in the single source. So I have all my data is available in one particular data source, that is a MySQL or in Oracle or in Teradata example. At that time, data joins is the best option. When do we use the data blending? My data source tables are from different data sources. So one table I'm bringing from my MySQL, one table I'm bringing from Oracle, or one from Teradata or from Hadoop. You can use the data blending option. So the first table in the data blending is always the primary data source. And then the second one, we call it as a secondary data source. Now let's start with the first joins. There is a first table, orders table. We are already seeing in the orders table, we have the order ID. When was the order date, customer name, and the segment, what type of customer. Now from which country, which state, and the city, postal code, and which region is coming from. So now this is your information, geography information available, order information available, what product they are buying in, from which subcategory and category, and product name. Now after that, we have the measure sales, how much sales happened, how much order quantity they ordered, how much discount was given, profit generated. This is the orders table, transactional table, along with some of the customer information available. Now there is another table called a returns table is there. In the returns table, there is information about whatever the order ID was sold and then returned to the company back, that information is there. Now I want to understand from this particular orders table, how many are returned. What I'll do is I want to see from this table. So I'm dragging it, sorry, not the dragging. I'm going to the orders table here. Click on the open, all of you. Go to this one, click on this drop down, click open. When you open it, you will see a window. There is a into mark and you see a window here. This place, now you drag the returns table. When you drag it like this, you'll see a Venn diagram symbols. Okay. Now, joins in the joins. One is the inner join, left join, right, and full outer. So here, this is the place for, by default, it is giving you the inner join. Inner join is basically, it includes in both the tables only the matching ones. In the left join means all the left table fields available plus whichever the ones matches from the right table, it will give the information. Otherwise, it is a null value. For example, this is matching. So that is why it is you are getting returns table. The column called returned is there and order ID is there. You can see the order ID name and then the returned yes. Wherever there is no data, it shows null values. You have a right table. So this is called right join. It does exactly like a left join. And then you have full outer join. Irrespective of matching or not, all the fields from all the tables will join. Okay, let's do this one example in the Excel. How does this work? For example, there is a table A is there. ID, assume that customer name and sales value. So in the table A, customer name A, B, C, just giving some values. So this is a table A. Now we have a table B. Okay, so now when I do the inner join, what it will do is it will go and check in the table A. These two are matching and the table B. This is the inner join. Now the left join. The left join means all the data from the left table A, it will take. From the table B, it will check first whether it is there. Yes, it is there. The data will be given. It will check the C. C is there? No. So this is null. Will give you null. F it will check. It's not available. It is null. So this is the left join. The right join. First it will check all the fields here. Okay. So what it will do is, let's put it here. By default, all right table fields will come. Now it will go and check these two only matching from your left table. Here, these are all null. So this is the right join. Now the full outer join, it will take all the fields from here, also from here. So first what it will do is, it will check these two. Yes, it is matched. Now, C is not there here. It will give the null. Now it will go and check this one. Here it is not there. It is null. So this is called full outer join. Now I will take the left table because I know that my orders is my transactional table. So I want this one as my left join. I close it. When you close it, you can see this one. This is the logical table. And then your physical tables are orders and returns. Both are joined. And this is a final output for us. Always it will give the sample of 1,000 rows. You can take it up to 10,000 rows here. Just type it the number. You will get 10,000 rows max as a view. As of now, 9,994 are there. That is why it gives you exact number. You just need to go here and type after 100. You just need to add 000. Then you can see the 10,000 rows. So now our table is joined. In joins, what happens is always it is a physical join. So this means literally the two tables are joined and then you'll start creating your visualizations. So that is the reason we avoid most of the time the joins. Because in reality, our databases are huge. If we start actually doing the join, what happens is your file will become so heavy. So we always prefer either the relationship, most of the time relationship, yes. And when you have two different data sources, then we go with the blending. So that is the option. 1 second. So connecting to the multiple data sources, you can understand joins, inner, full join, left and right join. How do we connect? Suppose multiple data sources are there. We have seen the same Excel file where we have different sheets and we have seen the join, right? Now what we will do is, I have a different file table altogether. I want to add the US crime data, the another data set I gave, right? So I want to add that also. So what you can do is click on the add here, Excel file. Now go to that US crime data, the second data set which I shared. This is the US crime data. Double click. Now you see there is a sample superstore. In that the three sheets are there. Another data set that is called US crime data. You have a sheet 1 available. So this means two connections. One connection superstore data, another connection US crime data. We are going to do the join now. First is we just connected our data. So the next step is how do we connect it? How do we join it? So when you go to the sheet 1 here, again, I'll go to the orders table, click open. The same step, click open. Now bring the sheet 1 again here. In this sheet 1.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
I'm choosing again left join. Okay, so we'll wait here and then we'll learn how is the field is selected. Okay, in the previous one, because it is a same data set, that is a sample superstore, orders and returns, there are columns available. This is the orders columns, category, city, country, and all. There is an order ID is there. Now in the returns table, when you click on this returns table, you have order ID is there and returned is there. See what is happening is here, Tableau is deciding which is the common field between the two tables. In this, both the names are order ID. So that is by default it picked up. You don't need to do anything. But I want to select manually. Suppose sometimes maybe the field names are not same, or I want to do it manually. What you can do is click on this one, use choose. In the orders table and the US crime data sheet 1, city is a common field between the two tables, and also state is a common field. So I'll select second one. Instead of city, I want to choose state. And then it should match it with the state here also. State to state. Instead of city to city, Tableau decided city to city is the best match. But I want to select state to state. Because in both the tables it is available. I can choose. Or sometimes I want to join with the two fields. One state to state, another one also I want to add a new join clause. That is city to city. Now it has to match both state to state and also city to city while joining. You can match even that also. So what we have learned, one, Tableau decides by default which field to field it has to match from the two different tables. Base is the metadata name. If the metadata name of that particular field is same for both the tables, it by default it will match it. If you don't want the default option, you can choose manually by creating your own join field. Add a new join clause. You can do it manually. You can give equal to, not equal to, greater than or equal to, any choice of your symbols you can choose. Okay, so the next option we have is called data blending. Data blending is when the data source is coming, tables are coming from the different data sources. One will become primary and the relationship between fields need to be maintained manually. Now the question is, when I do the data joins, there is no question of either it is a primary table or a secondary table, because I can do the left join, I can do the right join. So there is no problem as such, that will be a primary or secondary. But in the data blending, it is always there is a primary and then rest all will become your secondary data sources. So typically in blending, it works like a left table join only in the data blending. So there is no kind of inner join or, right join or a full outer join. Only the left join works in the data blending. How do we do that is, Okay, before getting into that, I'll show how to remove the tables. Once you created which you don't want, just again go here, click open. I don't want returns. Click on the returns table, remove. The same way, click on the sheet one, remove it. Now we are back to only one order table. If you don't want even the order table also, go here, click on this, remove it. Now this is blank. So you have tables here. One is a superstore, one is a crime data. Even the connections also you can close it. Suppose if you have only one data connection, you cannot remove it. If you have two, more than one, what you can do is any one you can close it. I will go to the US crime data and remove it. Now it is removed. But sample superstore, I cannot. Yeah, I can remove this also. No, it's not giving the option. Yeah, correct. So if I have only one data source, I can never remove it. So here now you have a superstore data, only one data connection. Let's move to the, how do we create a blending? See, the moment you remove the data, right, automatically your sheets are also showing the red mark because it says that data is not available or sheet unavailable. Earlier I created the charts, right? Now the data is missing. So that is the reason you cannot see any dimensions or measures. So that is why this is an exclamatory mark. So the data is not available. As of now, I'm clearing the sheet. Now going back here, this is the part you can clear the sheet. If you don't want the sheet, just clear this. Sorry, this one. This is the icon, clear sheet. I started adding, I'm so sorry. 1 second. Clear the sheet, it will clear the entire thing. And the same way here also. Okay, so blending. When we are doing the blending, you need to bring in the data, another data source, not from here. You have to go to the sheet level, first of all, and then click on the data, new data source, this option. I'm repeating again. For the joins, always the data connections, you can give n number of data connections by clicking the add button here. This is the add button. For whereas the blending, first data source will be here. After that, n number of data sources if you want to bring, go to the sheet level, click on the data menu, click the new data source. So this is the option. The process is same, but it's just that you need to bring the next data source from the sheet level. Whereas joins at the data source level, but for the blending, always at the sheet level. So now I am bringing the data source, US crime data here. Okay, all of you who already completed, who already brought the crime data here, what you do is go to the file, click on the new workbook. Because you keep that one as it is. Now go to the file, click on the new workbook. I'm just opening a new workbook. So this is a new workbook, right? So here, the first step, first data source, go to the data source, click on the Excel, bring your sample superstore. So you have orders, people, and returns. Now just drag the orders and leave it here. Now it is prompting you to go to worksheet, right? Click on the sheet one on the task bar. Here, we are doing the blending. So go to the data menu, click on the new data source. Now bring the US crime data, Microsoft Excel, US crime data. Again, it will open a new data source page. For the blending, if you bring table 1, it will open a data source page. Bring in another table, it will open a new data source page. Bring in the table 3, it will open a new data source page. So for every data source, you will have a different data source page. Now drag the sheet 1. Now go back to the sheet 1 again. Here you see, there is a one table sample superstore. There is another data source, US crime. You can see both. You can toggle between these two. If you want to work with the sample superstore data source, you can choose a sample superstore, go to the data source. This is your data source. If you want to work with the US crime data, click on the US crime data source. So this is the US crime data. Now, when you click on the data source, it will show the US crime data. Now I want to bring in another one, Amazing Mart. Go to the data, click on the new data source. Again, Excel file, Amazing Mart. So this will open again a new data source page. I'm just dragging one table here. Now go to the sheet one. You have one data source, Amazing Mart, another data source, Sample Superstore, another data source, US Crime. So 3 data sources are there. You can toggle. When you toggle it, you can see that particular related data source fields. So at the sheet level, blending always happens at the sheet level, the data menu. In the data menu, this is the new data source. We learned joins. Now I'm going to do it with the blending. So to start with the blending, first table, I'm loading the sample superstore. So I'm dragging the orders table here. Now going to the sheet one. So this is what the sheet one, right? So we'll go to the sheet one. So there is one data source already there. So that is what our order sample superstore. This is the one. For the blending, we already learned that we have to load another data source from the sheet level. So go to the data, click on the new data source. Now this time I want to bring in the US crime data. So the moment you load the new data source, again a new data source page will open. So drag your sheet one here. So go back to the sheet one again. You have first data source order sample superstore and also the sheet one US crime data. So these two data sources, right now the relationship is not created yet. Okay, so we will do how to create a relationship. For the blending, whenever you want to create a relationship, go to the data. There is an option called Edit Blend Relationships. I'll repeat again. You have to go to the data menu. Click on the option called Edit Blend Relationships. So when you open this window, so what happens is the first table, it is showing as a primary data source. That is your sample superstore data source with the orders table. Now the second one is sheet one, that is US crime data. Here you can ask me, why is that, orders is a primary data source? Here you can change it. There is no as such that you have to be restricted with, whichever the one comes here. If I want to change my primary data source to US crime, you can change automatically. Sample superstore will become your secondary data source. The same way, if you want to use order sample superstore as a primary, you can change it. Now, there is a big advantage with the blending. What happens is in this page, that is in this sheet, you're planning to use your sample superstore as a primary data source to create a view. If I go to the next report, I want to use US crime as my primary data source. That also can be done. We will get into that later. Okay. But if there is a flexibility, every report you can change which is the primary, which is the secondary. Now the second step, it automatically selects the metadata. It chooses the metadata from both the tables and it will give you which are the ones can be matched. So in both the tables, city name is there, city name is there, state is there, state is there. So automatically the Tableau has selected these two are the matching ones. City to city, state to state. If at all you want to change it on your own, customization you want to do, you can click the option called custom. Okay. So this custom button, we will do it later. Let's focus on the automatic now. So already Tableau decided there is a city to city, state to state is there. We are good. So it is telling you that these are the relationships you can build. Now still the relationship is not active because I need to bring in one field onto the view, then automatically the relationships will become active. Now what I'm going to do is, because it said city to city, state to state is available. So what I'm doing is from the order sample superstore, I am bringing the state onto the rows. The moment you bring in a field from any of one particular data source, there is a small blue tick mark you're seeing here. So this means this is the primary data source. Primary data source is always blue color. So you're using the first field from the sample superstore. So automatically this has become your primary. For example, go to the new sheet, click on this one, new worksheet. If I use from the sheet one state onto the view, then US crime will become your primary data source for this particular worksheet. Sheet one, sample superstore, because I brought a field from the sample superstore. That is the reason this is primary. In the sheet two, I brought a field from the US crime. So that is the reason this is a blue tick mark. Now going back to the sheet one. So one field, that is a dimension I brought in from the sample superstore. Now one US crime, I want to bring the population information. So this is a measure. I want to see what is the population for each state. So I will drag this one onto the, instead of columns, as of now, leave it on the ABC. Drag and drop or on the text. Anything is okay. Population, drag it onto the text. So when you drag it onto the text, it will give you the table information. Now this is moved into the orange color. So this is called your secondary data source. So your sample superstore is in the blue color, which is a primary data source. US crime is in the orange color. While you see this one in the secondary data source, there is a small staple mark you're seeing here. So what it is doing, because you already have a relationship, state to state, you matched it, city to city is already there. So what it is showing is now you have used state as a linking field. So that is why this is enabled. If you want to enable city also, just go and click it. Then this is also enabled. So this is like a join, left to join. You're joining with the state to state and city to city. Okay. Now I do have a population information. I also want to bring the violent crime data. Just drag it onto the text again. And go to the show me, select this one. So now we have a population information, violent crime. These two measures we are bringing from the sheet one, that is the secondary table. Dimension we are bringing from the primary table. We are observing here, there are some of the fields which are not, the data is not available. So what does the left join do? Yesterday we learned, right? When there is a data, it will display the data. When there is no data, the null values. So these are all null values. So this means in your secondary table, population information, crime information is missing for some of the states. So that is showing as a null value. Now I want to bring another measure from the primary data source. I want to bring the sales value. You can bring even sales also. So sales has all the information because it is from your primary table. So that is why all the states has a sales data. But population is coming from your different table data. So that is why these are blank. This way you can identify if you want to actually update your crime data, you can update, or otherwise you just leave it. So these are all null values. You can't do anything. This is what actually the data is captured. Now the relationship, how do I build it? First of all, when I go to this new sheet again, there is no link between these two data sources. It's just that on a paper, it is created a relationship city to city, state to state. Until unless you don't use the fields, it will not be activated. So now I'm using the fields. What I'll do is here, I will bring the state from the sheet one crime data. Now here, if you bring sales information, now this has become your secondary data source now. In this, Alaska is showing null figures. So this means there is no superstore available in Alaska. So that is why there are no sales. And then I want to bring the population information. So you have a population information for Alaska and also the crime data also available. It's just that the sales is not available. So this means our superstore is not there in the Alaska state. So sheet 1 is your primary table is orders. In the sheet 2, your primary table is US crime. Now you can see the report differently. So total states available in the US crime data is 33 states. Whereas in the order sample superstore, the total states are available are 49 states. So that is the difference. This is the way you can blend it and you can create the reports. How do I actually create a custom one? Okay. Now what I'm doing is I'm also bringing in another data source that is called Amazing Mart. So I'll bring the list of orders here. So I do have list of orders, order name, order date and all. Yes, perfect. Now go to the sheet 3. You have all the 3, correct? For the relationship, when you go to the data, edit blend relationships. So it is already identifying. If my primary data source is Amazing Mart data, then with the sample superstore, what all the fields can be matched, it is already giving. Because all the metadata is same for both the tables. That is the reason everything is matched. If I select my second data source as US crime, it is also giving me automatically what all can be matched. Now for the customization, what I can do is I will click on the custom and then click the add. I don't want to match everything. So what I'm going to do is I just want to select only state to state. Click OK. Yes, this mapping will replace at least one existing mapping. We are fine. Okay. Okay. So now we have a new one, which is called state to state matching is done. You can remove all those things, these ones, which we don't need. Okay, let me first remove it off all because these are already identified by system and it is giving you the matching. In normal scenario, you will not get all these things matching, only 1 or 2 fields, but let me remove everything. Okay. So now there is no fields are matching. Now I will create my own. Click add. So here you can match it with the country to country, city to city, state to state. For example, if I want to match region to region, I will give region to the region and click OK. So now your custom created one. There is a region to region. I want to add another relationship. Click add. So this time I want to match it even with the state to state also. Click OK and OK. So now we have defined instead of automatic, we have done the customization. We want to match list of orders with the sample superstore, only these 2 columns to match. Click OK. Now go here. From the list of orders, bring your region. Now when you go to the sample superstore, because you created your relationship, region and state only, so that only getting identified. Otherwise, you go here, when you go and bring a region, when I go to the sample superstore, so here you can give even state also. Now bring the state from here. When I gave the region is able to identify, but state is not able to identify. State is giving us the null values. What could be the reason? So because your data of Amazing Mart states are UK and Europe data. Let's go and see this one. When you bring the state, so these are all UK and Europe data. Okay, but the region is same because you have central, north and south. And even in the sample superstore also, the region is same. So that is why region to region is matching. So first level of blending, the relationship is happening at the metadata level. While once the metadata level, you created the relationship, on the view, what happens is it will check the data to data. Now, the data items in that particular field, it will check. If it is matching, it will give you the information. It is not matching, then it will give you null values. So now we have defined region and state. So that is the reason we are not able to see the state names because state names are different. Now what I'm going to do is I'm going to bring in another data set that is called coffee chain data. Again, I'm doing data, new data source, Excel, sample coffee chain data. We have in the table area code and all. Okay. I want the location information. Perfect. Yes. So I'm going to bring the location table where I have the state name, market, and market size. So the state name now can be matched with the state to state. So when you go to the data, again, blend relationships. Now you have a sample coffee chain. Sample coffee chain can be matched with the Amazing Mart for the state to state. Sample superstore also, it can be matched with the state to state. Crime data also, it can be matched. So automatically it is telling you the same metadata field is available in all the three tables. So it can be matched. It's automatic. So click OK. Now go to sample coffee chain data, bring the state onto the rows. Now, whichever the table you want to select now, you can select. So what I want to do is I want to go to the sample superstore. First, I want to bring the sales information. So sales is coming from the superstore. And I want to go to the crime data. I want to bring the population information and also the crime information. And from the Amazing Mart data, I want to bring in the orders count, for example. So nothing is matching because again, your sample coffee chain data is United States. Whereas your Amazing Mart data, it is UK and Europe. That is the reason everything is blank. So this is called data blending. Like you can add as many tables as you want and you can link it. Automatically it will link with your blend relationships. If not, you can do with the custom. Okay, so this is the blending. Just a moment, let me go back to the. So when is the blending useful? When the data source tables are from the different sources, you can use the blending. One data source is always the primary and rest will be the secondary data sources. And the relationships between fields, it automatically gives. If not, you have to maintain it manually. That's about the blending. Apart from the blending, we also have a new feature called relationships. So this is called logical table joins. Whatever we have done in the joins, so this is the physical table joins. What it is doing, it literally combining two tables together and creating a new table. So that is a join. Whereas blending, it is not joining the tables. It is joining the fields, while when we want actually to create a view, at that time, the data is pulled from the different tables. Now, what relationship does is, it will just create a relationship with every table. And then later you can use it if you want to use it on your visualization. So now for the relationships, this is a recent feature version from the 2020 version onwards they've added. Now, most of the work, like what you do in the joins or blending, you can do it in the relationship. So this is the best way to connect your data sources and create relationships. So how do we do that is now I am bringing the new data source. You can bring it from anywhere. So I want to do it from the data level here, new data source. Microsoft Excel, and there is a bookstore data which I shared with all of you yesterday, right? So take that data set, bookshop data. Now, this is the bookshop data. In the bookshop data, you have all the tables available. There are almost 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 tables are there. Of course, these are all sheets, but we consider as a tables. Now, let's create a relationship for each table. In the relationships, it is represented with the noodle line. There is a line representation that is a noodle line. So first one, I want to bring the author table. Okay, let's see what are the fields available. In the author table, you have author ID, birthday of the author, country of residence, the author first name, last name, and how many hours they have written. So I'm dragging this one here. So you need to open the particular first table and then you have to drag in. That is the join. But whereas a relationship, you don't need to open it. I'm just dragging another table like this. So this is called a noodle line. This is a relationship. Just drag and drop. Now, if you all see, award is not actually getting linked here. So it is saying the relationship has no matching fields. So that is why it is unable to join. So this means the relationship is unable to build. Here it is giving you the option. You can select. If what it does is a Tableau by default, again, it will check what are the common metadata field names, and then it will try to connect it. If it is not, then you go ahead and check. This is the author table. What fields are there? Author ID and all. In award, what fields are there? Award name is there, title is there, year one. So there is nothing common field available here. So I cannot match it. Remove this one. Now go to the book. Click on this book and see. Yes. So you have an author ID is available, book ID is there, and title is there. So in the author table, I also have an author ID. So now this will match. What you do, drag the book. Now automatically there is a relationship is built. It is showing author ID to equal to author ID. So there is a matching. Now, like I said, relationship is only a logical relationship. You will not see both the tables together here. If I click the author table, I can see the author table here. This one. If you click on the book table, you can see the book table. It's just a relationship is built now. Now you can see what is the relationship. Author to book, there is a relationship. Cardinality is many to many. So there is no one to many we are preparing here because they are repeated fields available. That is why many to many we gave. That also you don't need to worry. Cardinality by default, Tableau only will check and will assign the best cardinality. If not, if you want to change it, you can do it on your own. That is, click on this one. Performance options available. You can choose the cardinality. Many to many is what the Tableau decided. That is the best option. If you want to change it, you can give one to many or one to one or many to many, up to you. What is a referential integrity? It will tell you some records match, many to many. If I choose many to one, this will aggregate data and all. So this is up to you. You can decide. But right now, I'll go ahead with the what Tableau suggested. I'll keep it as a many to many. Now there is a relationship is built. We are good. So as of now, everything is available from every table. We can use it by building a relationship. Okay, so now from the book table, we have a title is available, author ID is there, book ID is there. Now go and see the award. Award can be matched now? Yes. In the award table, there is a title is there that can be matched with the book table. So just now drag the award to the book. There is a relationship between now author to book and book to award also. When I'm creating a view, if I want to bring author ID and award details, I can easily bring because in between there is a book relationship is there. So that is the beauty of relationships. Okay, we will learn it while creating the views. Now the next one, there is a checkouts is there table. In the checkouts, we have book ID is there. So it will match with the book. It cannot be matched with the author or it cannot be matched with the award. So just bring the checkouts to the book. So this is the way like this. Whichever the table you want to match it, you can choose. So checkouts can be matched with the book. And one more thing, if you are in doubt, if you don't know which field will match, what you can do is simply go here and double click on these tables. Suppose I don't know addition, what is there, and I don't understand to which table it will be matching. What I'll do is I'll just double click it. It will go and match it with the best option. So it will check and it will match it. So addition is also matching with the book. So that is because the reason is in the addition table, you have a book ID and in the book table, you have a book ID. So it is matching. So when in doubt, just go ahead this way. Now again, info table. This also I'm double clicking it. I'm not seeing like, which field will match and all these things because it takes time for me. I'll double click it. Now info is trying to match, but it is unable to match it. So that is the reason it is giving you error. Okay, as of now, let's remove the info part. I'll tell you later when to use it. Now click on the publisher, double click. So publisher is matching with the edition. That is why it is going ahead and getting updated here. So it can be linked with the edition. Now we have a ratings. So ratings can be matched with the book ID because the reason is you have a book ID in the ratings, also book ID in the book. Okay, I'm stopping here. Now info table is not matched, right? Let's see why this is not able to match it. Now I'm clicking on the view data. In the info table, there is a book ID 1, book ID 2 is there. But still it is unable to match because the first thing is the metadata is not correct, means it is not same. Second thing is in the book ID, in the book table, the book ID is the alphanumeric. That is the book shortcut name and then the number. Whereas in the info table, what we are seeing here is they have done the split. That is the reason you are seeing the string values separate and the numerical values separate. In the book table, it is concatenated. Here, there is a split. Now, how do I use this one and make a relationship? So that's the where there is a relationship, join relationship calculation field will work. So what you do is now bring the info to the book like this, drag it. And then there is an exclamatory mark you're seeing, right? Click on this one. Here, now go manually and select it. So what I'm going to do is manually, I will select from the book table, book ID. And from the info table, if I concatenate these two, then only it will match with this. So now I'll write a calculation here. Click on the create relationship calculation. You're all seeing, right? When you click on the select a field, you have options available. It is not matching with this. So what I'm going to do is I'm creating a relationship calculation. Click this one. So this is a calculation box will open. Here what you do is type book. So it is prompting you. So this is a field 1, book ID 1 plus book ID 2. So what it is doing, it will add these two, it will concatenate these two, and then it will match it with the book ID. Whenever you write a calculation field, suppose if you're doing a mistake, for example, I have not closed the square brackets. Like this I typed. It will tell you the calculation contains errors. You go ahead and see what is the issue. Column name missing. So go and fix it. Close the square. Now the calculation is valid. And then click apply. And click OK. Now this is, the relationship is built. Just a moment. Now we all can see the data is updated. That is, now the exclamatory mark is gone. So book to the info, we are able to create a relationship. So like this, we handle, suppose if the metadata is not matching, or if there is a split of one column into 2 fields or 3 fields, how do we concatenate and match it? This is the way to do it. Now, we have done the ratings also. Now there are sales tables are available. All the 4 quarters, we have sales tables available here. Before we get into this one, let's bring the series also. Now we bring in the series, info to series, edition to publisher, and author to book and all. Now, how do we use these sales tables? Again, the same way you can create a relationship like this, sales Q1, Q2, Q3, and Q4. So now we have all the 4 tables also linked. But there is another way of doing it for the tables, sales transactional tables. We have another option called union is available in the Tableau. So we learned joins, we learned blending, we are doing the relationships. There is another option called new union.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
What we can do is we can add all the tables into one particular table. Joins will happen at the columnar level. Union will happen at the row level. So when you have various months data, if you want to create one table for all the months or all the quarters, you can use even the union also. So how to do this one? What I'll do is first I'll remove the Q4, Q3, Q2. Yeah, the first step is you bring this Q1 now. This Q1, what you do is click on this Q1, convert to union. Select this option. When I convert to union, this box will open. So what it will union? It will union Q1 is already there. Just bring the Q2 in this, bring the Q3 in this, and the Q4. Now this table will become the combination of all the Q1, Q2, Q3, Q4 and apply. So tables in union, 4 tables. Click OK. So this table is unioned with the 4 tables. And then go here and see. I'll give from 100 to sample rows. I want to see 10,000 rows, whether it is union completed or not. We can check like this. See, you have the Q2 table also. Like that, you have Q1. So all the fields are there. All the 4 tables put together, total 56,350 rows are there. Now it's just that you need to go and change the name. Click on this one, rename it. You can say total sales, all quarters. All the 4 quarters data is available. So we have created a relationship now, author, book, and everything. So this is the way you can. So now you all can ask me a question. For example, we added all the quarters data here. For example, if in this table, ISBN, item ID, order ID, sale date, and the discount. Even if you click on the Q2, so the same metadata. What happens if there is a different metadata? That means, suppose this table has ISBN 1. This field has ISBN 1. This field has item ID 1. How it will join? That is how it will union. Let's see that also. Back to this table again. I am adding again new data source, Excel. I've done some, different file. I'll show. So here, if you see in the Q1, what I did was, these names are okay, that field names. In the Q2, I changed the field names. I've changed the field names. Okay, it's not done. Just a moment. Give me a second. Let me change the names. Okay, so now what I've done is I've done the changes like, in the sales Q1. Are you able to see the sale? Yeah, Excel file, right? Okay. So here the metadata is sale date, ISBN, discount, item ID, order ID. In the sales Q2, what I did was I changed this field name as ISBN 1. Here it is ISBN and this is ISBN 1. In the Q3, I've changed the item ID to item ID 1. And Q4, order ID to order ID. Now, if I load this file, how does it work? Let's see that. So if I bring this one here, and then I convert this into the union, convert to union. Now, if I add the Q2, Q3, and the Q4, right? So now what is happening is, because there are different names, ISBN, there is ISBN 1, item ID 1, order ID 1. So there are different names. So wherever it is matching, it is giving the information. Rest all it is giving the null. But when I know that ISBN and ISBN 1 are both are same columns, how do I merge it? So what you have to do is go to this part, your metadata part. Go to the ISBN, the first field, select it. Okay. So just a moment. So in the latest version, there is no option. No, it should be available. That's what I'm trying to see. There is a merge option available. sale date, ISBN, item ID. Create a group. Okay, so I don't know why this is not giving the option. Okay, let me figure it out. Normally what it does is it gives the option of merging two different fields. Okay, I think I need to select, sorry. ISBN and ISBN you selected with the control button and click the right click, merge mismatched fields. Because we know that these two fields are same. Only thing is because of the name difference, it is showing two different fields. Now I want to merge it. So what you have to do is select those fields, ISBN, ISBN1, and then right click, merge mismatched fields. Now what happened? These two become into one column. The same way, item ID 1 to item ID. Right click, merge mismatched fields. Now we have item ID 1 and item ID 2. Next one is order ID to order ID 1. Right click, merge. Now we got the issues resolved. What you can do is you can rename it. Just go here, rename it. This is called ISBN. And this is item ID. Rename it. Instead of item ID 1 and item ID, just rename it as item ID. This is the result of merging the mismatched fields. Like that, you can match it. But here, the remote field name will show you what actually you have done. So whenever you want to refer it back, you can see that this is ISBN and ISBN1 together into one field. Item ID 1 to item ID into one field. Now, earlier one, when we have done the bookshop relationships. So in this case, what we have done is we have done the relationship plus also the union we have done. If you don't want the union, you can also directly give the relationship, but that is also possible. Now, the next part is, can I do the joins, blend, and also relationships together? Yes, that is also possible. You can do all these things and still you can use the reports and you can create the reports. It's not that if I'm using only the blending, then I have to go with the blending. No, you can use the combination of joins, blends, and relationships also as per your requirement. Now, how do we do that here? I will click the add button and then bring another data source here. Just a second. Oh, application error. Okay, so I need to open it again. It got closed. So now, right now it got closed automatically. It is opened the last whatever I've created. So yeah, so it is available. So what you can do is now right away you can save it, this file, and then you can start working on it. So now if I want to add another table, click add Excel. So I will bring in, for example, sample superstore. I also have another data set that is a sample superstore. If I want to do the joins with anything, I will open that particular table and click open, and you can do the joins from here if you want to join it. Right now, this will not join. The reason is nothing is matching. So I'll go with the full outer. Even with the full outer also, it is unable to identify. So if I want to calculate, create a join calculation and do. But as of now, these two are totally different data sets. So let's not do this way. We'll remove this one and close it. Or we should go to the sample superstore here. Let me open the data source of sample superstore. Here, what we have done, we have not joined anything. So here also you can build the relationship. So with the people table, I want to create a relationship. But for the returns table, I want to create a join. So I'll go to the orders, open it here. Returns, I'm doing the join. So that is the left table join I'm choosing. So here in the orders, returns is part of join and people is part of relationship. I can build this way. So both the things you can use it. So when you go here with your sample superstore, you have the table, people table separately we have taken. But with the orders table, you already have the returns and order ID. Order ID and order returns. So those two are part of your same table. That is this join. Here it is. So this is the way you can do combinations if you want to do combinations with the blending, relationships, or the joins. Now let's go back and understand the features one by one. So this sheet will help you in understanding the features. And this is the data model. Your relationships are logical, whereas your joins are physical. So that is why you're seeing here Venn diagram. This is a physical layer. Whereas the logical table, your relationship is the logical table. Now, every feature we'll discuss now. When did this relationship is introduced? It is introduced in 2020.2 version onwards. Whereas the cross database joins and the data blending already in use. So this means when they launched it, these two are available. This is a recent one. How do I connect second data set, third data set, or nth data set? In relationship, what we do is we go and keep on adding here the relationships. Also in the joins also, we add it here. Second data set, third data set, nth data set. Whereas for the blending, you always need to go to the sheet level and then start adding the new data sources. That is what we have done here, right? So that is the difference between relationships, joins, and the blending for the data set addition. The third one, in what layer this feature is used? Like I already said, relationship is a logical layer. Database join is a physical layer. Whereas in the blending, it is at the worksheet level. It is. The next feature, the data source pages. For the relationship and the database joins, it's a common data source page for all the data sets you're connecting. Whereas the blending, every data set will have a separate data source page. So what does this mean? Here, if another data sets you're adding, for every data set, the common data source is the same page. For the relationships or for the joins. Whereas for the blending, when you click on the order sample superstore, it will open order sample superstore. When you click on the author data source, it will open the author data source page. When you click on the list of orders Amazing Mart, then you can see the Amazing Mart data source page. Like that, for every data source, there is an individual data source page available for the blending. Whereas for the relationships and the joins, it is a common one. How is the data is joined? In relationship, it is only a relation it is getting built. The data will join at the visualization level. So that is, when I want to create a view, here is the time the data is joined. So I can take author ID from the author table, award name from the award table. I can take book title from the book and sales. Total sales, I can bring it here, count of total sales. So like that, you can use all the data fields at the visualization level for the relationship. Whereas for the joins, first it will happen at the data source. Data is first joined at the data source page and then you will use the fields. And again, blending also only at the visualization level. So relationship and blending, the data, you don't need to join first and use it. First you build the relationships and then later you can use it for your visualization. So that what happens is your data will not be loaded with the MB space or GB space or whatever it is. And what type of joins you can do? In relationship, it is flexible. You can decide on your own, or you can go ahead with the Tableau, the best option. Otherwise, if you want to change it, you can go ahead and change the performance options, many to many, many to one to many, or one to one. It is flexible. For the cross database joins, you have only 4 options. That is inner join, left outer join, right outer join, and full outer join. Whereas in the blending, you have only one option that is called left join. You can only do the left join. Of course, a small kind of, what do you call, you can tweak it and you can use the inner join also, but that we will learn later. But as a thumb rule for the data blending, it is only a out left join only. How is the representation made? For the relationship, it is a noodle line between the tables so that we can easily understand. If there is a line between 2 tables, then it is called a relationship. Whereas for the joins, it is a Venn diagram. That is a join symbol. For the blending, you already seen that blue color and the orange color tick marks. When you use it, you will see the red, orange color and the blue color tick marks. Whereas for the relationships, so this is the noodle line. So the order of executing joins and aggregation. For relationship, it is flexible. If you want to join it and you want to aggregate, or you want to aggregate it and join it, you can choose. There is no restriction. But whereas the joins, first you have to join your data, then only you can do the aggregations. Aggregations means nothing but your dimension level aggregations or measures where you can show the sum or product or whatever it is. In the blending, data is aggregated and then joined. That's what we have done here, right? So this is aggregated and then joined. So first you are bringing the state level. So there is aggregation is happening at the state level. And then you're joining with the other table for other measures. Now, difference in levels of hierarchy, duplication of records. So here the duplication is avoided because you're just creating a relationship. So it aggregates, right? At that time, duplication is avoided. But in the joins, because you are physically joining the tables, if there is a duplicate record, it will be there. Always a duplication occurs in the physical join. That is a cross database join. Yeah, blending also duplication is avoided because first you will bring the aggregation, right? You bring the dimension and then on top of it, you're doing the aggregation. So the duplication is avoided. What is the requirement for all the 3 features? You need the primary key. At least one primary key is required to match it. How do we choose a primary key? Tableau does automatically for all the options, or else you can do the changes by clicking on the relationship. Like suppose there is a state, city is also there. If you want to choose it, you can choose it in all the options. The calculations, the join calculations, I already shown the relationship calculation, which can be used. Even in the joins also, you can create a calculation. But in the blending, you cannot create any join calculation. It is not possible. Because it is only a left join. That is the reason it cannot be used. Flexibility of deciding the join type. What type of join I want to do? It is a flexible. Like I said, many to many, one to many, one to one, and so on. I can do it. I can decide anytime. But whereas for the joins, you need to decide first the join type, either inner join, left, outer, or right, or full join. First you decide the join and then the tables are joined. Whereas in the blending, it is flexible again. Okay, so the last 2, data pane. What is a data pane? This is called data pane, we call. You can see the tables, right? So this is called data pane. For sample superstore, what we have done is we have created the joins, right? That is the sample superstore, right? So in the data pane, suppose if you join it, orders and returns are into one table. So when you do the join, it will merge all the fields into one table and it will show here. So this is order ID returns. And whether it is returned or not, that information is here. So two tables merged into one table and all the fields together, it will show first dimensions and the measures. Whereas when you create a relationship, what it does is every table is separate. You can see every table dimension measure, dimensions measure, again dimensions and measure. Every table you can view because it is not physically joining, right? So that is the reason all tables are here. You can choose. The same thing with your blending also. Blending, you have different tables here. All the different tables you can choose. This is called data pane. The last one, when to use which option. The relationship is the most recommended because of its flexibility. And joins can be used depending on your data. If your data is not huge, you can go ahead with the join. This means your tables are like, if it's not heavy, you can go ahead with the join also. Nothing wrong. It's good. But it's just that, don't go with the large data sets, do the join. It will become slow. When to use the blending? As required depending on your data, especially when working with the published data sources. At that time, you cannot create a relationship. So that time you go ahead with the blending. So that is the last choice. If it cannot be done at the relationship level, you go ahead with the blending. Otherwise, every work can be done now, 99%. You can go ahead and do with the relationships. That's about the features of all the three options, when to use it and when to not use. So now what we have done is with this, we have completed the metadata and also the how to do the how to connect various data sources. Okay, so here are the data blending features available. So the data blending is something, it helps user combine two different data sets that might be related to each other by some common attribute. Tableau automatically tries to link two data sets based on the column names in both the data sets. Automatic relationship can be edited by clicking the data menu on clicking on relationship. Data blending should have used when you have related data in multiple data sources that you want to analyze together in a single view. Now, Tableau only supports the left to join in the data blending. You must change the order of data sources for right outer join. You all remember that's what actually we have done. In the sheet 1, we made the sample superstore as a primary and then we use the crime as a secondary data source. While in the sheet 2, we did the reverse way because I want right join. So that is the reason what I did was first I use the US crime data as my primary and sample superstore as my secondary. And for inner joins, yes, this is what I said. In normal cases, you cannot do the inner join. But to do the inner join, there is an option called you need to filter nulls. So that is what we go here. And suppose if I want to actually remove these blanks, what I'll do is I will remove the nulls. That is, go here, just bring the population. 1 second. Yes, right. Bring the population onto the filter. Take the sum. And then in the special, take non-null values. This one I will repeat in the filters. So don't worry if you're not getting it, that's fine. But I'm just showing the feature. So here is the one non-null values you can select and click OK. Now this is called inner join. So this is the way you can do some tweaking and you can create an inner join in the data blending. What you have to do is you have to bring the measure onto the filter and then choose that in the filter option special non-null values. Cubes are not supported in the secondary data sets. So this means OLAP cubes, you cannot connect it for the data blending as a secondary data source. You can use it as a primary data source, but cubes cannot be used as a secondary data source. So this is the best example to see how the data blending looks like. For the primary data source, you can bring the data from data warehouse, data marts, files, and cubes. Whereas for the secondary data source, you can use only these three except the cubes. Because cubes are already aggregated. Already the dimension is created. So that is the reason you cannot match it. So we always get the doubt when to join and when to blend. Of course, now the relationships have come, so the problem is also solved. But otherwise, how to decide? If all the data resides in one data source, go ahead with the joining. Because it improves your performance and the filtering control. If new data or table is added in the same data connection, join is always better. If the data source contains too many records, like I said, too much of data is available, then go ahead with the blending. Because joining is literally like, it takes so much of time and the performance issues will come. That is the reason, go ahead with the blending. And when both the summary and details need to be showcased at the same time, data blending is preferred. So all these things will be done using the relationship. So don't worry. So you can go ahead with the relationship. Okay. So now how do we do the extracts? Now we learned connecting and all. How do we do the extracts? Data extraction is something. Extracts are the saved subsets of data that you can use to improve performance, to take advantage of Tableau functionality, which is not available or supported in the original data. This means now whatever we connected as of now, everything is in the live, right? So all live connections only it is showing. So now all the data sets, you can just click on the extract button and you can create a extract table, which is called hyperfile. So anybody can now connect this data and they can use it on their development of their reports. So this is basically a subset of your data from the tables which you are bringing from your data sources. When you extract your data to create an extract, you can reduce the total amount of data by using filters and defining other limits. Suppose my data set has a 10-year data available in your databases. You have some 10 years data available. I don't want to use all the 10 years data. But when you connect your data or database, automatically it will connect to the entire data. So at that time, you can use a filter option where you can choose a filter on your data. Like I want to load only the 2 years data, 3 years data. And then you load it and you convert that into the extract option. That is, suppose now the sample superstore is there. I will convert into the extract and edit the extract here. Okay. I want to give the filter. In this filter, I want to give the order date. I want the years of, there are 4 years data available in our data set. I don't want to add entire data. I want to choose only 14 and 15. This is sufficient for my analysis. So I will take only 14 and 15, click OK. Now OK. So now your data is from 9,994 rows. You already filtered 2 data, that is 2 years data, which is now only 14 and 15. Is it not updated? Just a moment. Date. Year of order date keeps 2014 and 15. Yeah, so this is on the physical tables also. Why is it not showing? Yeah, I need to save. Now I'm saving it. Extract file, which is Superstore data, 2014 and 15. Refresh. Give me a moment. This data is still 48. Yeah, so now you can see 2014 and 15 only. Now we created a subset of this data, which we are going to use it for our. Yes. This is only 2 years data. If you want all the 4 years again, go here, edit, select this one, remove, and click OK. And then you refresh it. This is the button, refresh it, or here you can refresh it. Now go back here into the sheet. Now all the 4 years data, 12, 13, 14, and 15. All these things we will learn, but I'm just showing the option it is available. So this is the way you can limit your data by taking the filters option. After you create an extract, you can refresh it with the data from the original data. Now I've done 2 years data. Again, I took back the 4 years data like that. You can do the refreshing. When refreshing the data, you have the option to either do a full refresh, which replaces all of your extracted contents, or an incremental refresh, which only add rows that are new since the previous refresh. That we can choose it. That is here when you go here, when you're doing the refresh here, I can do the incremental refresh or the full refresh. So while you select all rows, then automatically entire refresh will happen. You can choose the incremental refresh. From the incremental refresh, you have an options. Table to refresh, orders table. How to identify the incremental refresh? You can choose by date, by postal code, by quantity, by row ID, by ship date. Which are the options you can choose it? You can choose from here. So I can go ahead with the order date because all the transactions are updated till yesterday. Whichever is getting, sale transactions happen today, that I want to update using the order date. I can give the order date, take the last order date, and from there you can give. So like that, you can choose the incremental refresh. So data extractions, why to do the data extractions? That can do the following, that is, they improve performance. For a file-based data sources such as Excel or Access, a full extract takes advantage of the Tableau data engine. For large data sources, a filtered one, like years, we can filter it, or you can reduce the geography information. Maybe you want to take entire world countries information available. If you want to use only one particular country, you can do those kind of filters and you can take the limit. They take advantage of Tableau functionality that is not available in the original data source, such as the ability to compute count distinct. You can use the count distinct also. We will learn it. You can go into the full offline access mode. Once you extract it, you don't need the internet connection or your server connections. Using the offline mode, wherever you are, even if you don't have internet connection, you can still work on your data sources. So that is the advantage of extracts. So again, these are the same steps for the extraction. You can choose a full extract, which I've shown, full refresh, incremental refresh. So with this, we've learned how to do the extractions. So we have completed the entire module. In the module, even initially we discussed about learning about what is data visualization and analytics, the power of Tableau and overview. We learned how to connect the data sources. We learned the products. The live and extract we understood. We have done the joins. Learned data types and data preparation, field types and file types. We already installed our Tableau desktop. A bit about architecture, but we go in detail in the later part. And how to start with the Tableau we learned. We connected the Excels, PDFs and cubes. Cubes I don't have because mine is a individual usage, right? I don't have the organizational data. The same process. How do you connect the Excels and PDFs? The same way cubes also will be connected. We learned the metadata and extracts. Okay, null values we have not done. I will show how to do the null values. We learned the joins, blending, and also the relationships and the data extraction. So from now, the next module onwards, we are going to do the 75% of the time, we are going to do the hands-on. So we'll be working on various kinds of filters and like how to write calculations, how to do the parameters and all. Okay. So today what I'll do is I will start with explaining about this part. So I'll just show the next module and then we'll move to this one. Okay. So the second module is we are going to cover filters. That is from tomorrow we're going to do it. All types of filters we will learn. There are 7 filters, are there 7 types. We will understand how to use the dimensions and measures. Marks card I will teach today. We can, how to create groups, how to create hierarchies, sorting and highlighting, and then creating the sets and bins. So this will be covered tomorrow. Okay, let's go to our Tableau. Now, this part is called data source. Okay, now this part is called data pane. We call it as a data pane. And this space is the space where it's a whiteboard where we create the visuals and columns and rows. You can choose dimensions either in the columns or rows, and vice versa for measures also. Anyways, like, the view will be different, that's all. The same fields you use. Now, this is called pages. This card, this is called pages card, where you do the animation. Whenever you want to bring in the animation, you can use the pages. And again, for the animation, it is a time period is required. So then only you can show it in the animation. So this means a date column is important. This space is for the filters. You can create various filters. You can create interactive ones. You can create user filters, and all types of filters you can create using this box. Everything is like a drag and drop. Even if for the filters also, you just need to drag and drop. For the pages also, you need to drag and drop. Columns, rows, drag and drop. Even here also. Now, this space is called marks card. In this marks card, this is a type of chart you can choose. There is a color option available wherein you can bring the color coding to your visualization. This is a size. You can increase and reduce the size of your visuals. Text is the place for the labels. Once you create your visualization, you can add the text. That is basically your data labels. That is the text. Detail is something wherein you will get report in detail while you bring something on the detail view. You can go to the drill down at the detail level. Now there is a tool tip. Whatever the fields you use it on the columns and rows, that will show on the view as a tool tip.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
So let's start with one simple visualization, that is subcategory onto the columns and sales onto the rows. So it will recommend what is the best view, best graph for the dimension and measure you have chosen. Of course, you can change it, but this is the, as of now, a bar graph is created. In this, there is a show me button available on the right hand side. You all can see. Here, there are predefined charts are there. There are 24 predefined charts. Some of them are enabled, some of them are disabled. It depends on what you're bringing on the columns and rows. It will automatically enables, you can choose any of this chart type. So now for this kind of one dimension and one measure, I can use a bar graph. I can use a text table. I can use a heat maps because these are all enabled. I can choose, but I cannot choose a graph. That is, I cannot choose a map because it is disabled. It is not possible. For this kind of dimension and measure, it is not possible. Even area graph is not possible. Even line graph is not possible. So sometimes when we are in doubt, we don't know what type of chart we want to use, go ahead with this one. It will always give you the best one, but still you can, if you want to change it something, like I want to go ahead with the pie graph, go ahead with the pie graph. But as of now, let's keep it here. So this is what actually the 24 charts are there. All the charts we're going to learn plus Some of the advanced charts also we will learn. Okay, so let's close this one as of now. Now from the marks card, it is selected automatic. If I want to choose line, you can choose line now. Here you cannot choose it, but here from here you can choose the line. But you think, is it good? Line is always associated with your trend line, right? Maybe, this is not a good chart. Area chart. This is also doesn't make sense. Square. Maybe you can choose this also. So like that you can choose. So this option is for your chart type. And by default, automatic, whatever is there, just go ahead with the automatic as of now. Now, color part. Color works in two different ways. When you bring the dimension onto the color, every data item in that particular field will be assigned with one different color. That is, I want to differentiate every data item with a different color. That is, accessories a different color, appliances different color, art different, binders and different. I want to give a different color. So what I'll do is drag the subcategory onto the color. Now you can see every bar is different with a different color. That is, your data items are. Because these are all discrete values, that is why it is giving you one color for each bar graph. Now, I don't want to give the subcategory dimension onto the color. I want to give measure onto the color. So when I bring the sales onto the color, because that is a measure, right? We are using. Here, what is happening? One single color with a different gradients it is showing. That is a lighter to the darker version. So it is giving you, if the value is less, then it is a lighter color. If the value is high, then it is a darker shade. So this is called a gradient color. Because your measure is a continuous value, that is why you will get a single color with a various shades. If I want to change different color, click on the color, edit colors. So in this edit colors, you have options. Blue is by default automatic. I want to change it. You have options, orange, apply and see. I want to change it to the green color. Or you can use the rack tracker color, that is red, amber, green. Go ahead and see. Red, green, gold diverging. Red is the low values, that is why it's in the red color. Next is the amber color, it is the better than red, neutral. And then green, which the sales is good. So you can use this one for measures. So maximum 3 colors you can use it for the measure. Or green, blue diverging, 2 color diverging. Or a single color with various gradients. That is a single color with the various gradients. You also have an option called stepped color is available. You can choose the steps, how many steps you want to create in this. Right now, by default, 5 it is giving. I want to choose only 3 steps color. Apply. So it takes the 3 steps, one lighter color, one medium color, and one darker color. If you want to use it reverse, for example, I'm using orange, blue diverging. So orange is like a less value and blue is a good high value. I want to use it in the reversed mode. Select the reverse. Now orange will become your high value. Blue will become your low value. So this is called reversed. You can use the use full color range and click on the advanced. If you want to give the colors like start date, start value, end value, and what is the center value, you can decide. This is the center value. And then click apply. Okay. So these options are available for the measure if you are bringing a measure onto the color. So the color can be chosen in 2 ways. One is the dimension or one is the measure. Suppose if I'm choosing the dimension again, that is a subcategory. So there is a single color for each data item. I want to change this orange color into something else. I am not liking it. This is a light blue. I don't want. So what you can do is click on the color, edit colors. Here already assigned. Now for the appliances, I don't want the light blue. I want this one. This is teal color. I'll select this one. Now it is changed. Apply. So remember, this is the second one. We are changing it. Now this is changed to the teal color. For the binders, I'm not liking the orange. I want to give a red color. I'll choose the red color and apply. Now this is red. The chairs is also repeating with the green, which we don't want. So I want to choose a different color. So I'll go here, select something from here. I want from the lighting color safe. In this, I want to choose this blue for the chairs or this one. Apply. Now this is a different color. So like that, you can choose from the color palette, whichever the colors you want to choose. It's up to you. You can decide. For the machines, I want to go ahead and choose the watermelon colors. Maybe this is the one. So this is called the color option. Now for the colors, sorry, not the colors. Now the tooltip. You remember I was talking about the tooltip. Tooltip is by default you're seeing, right? When I hover around on any particular bar, I can see the name subcategory sales. So whatever you use it on the columns and rows, by default, it will show on the tooltip when you hover around like this. So this is a subcategory and the subcategory name is accessories and the sales value is 167K. That's what here 167K. Suppose there is a detail option available. In this, I want to bring in a detail one. So for every subcategory, I want to bring the category, so not the category, segment information. I'll bring it on the detail. Okay. So when I go like this, there is a segment box it is created. So in the consumer, sorry, in the accessories, consumer segment is this piece, corporate is this one, and home office is this much. So this is called detailing. Okay, so this detail will be useful when we are working on the LODs, which is called level of detail expressions. We'll learn it later, but this works like this. Okay, right now we don't need, you can just remove it off. Now, size. So what the size will do is, whichever the field you are bringing it onto the size, it will change accordingly. Normally the size, we do it with the measures. Because measure is something, right? You're counting, you're aggregating it. So if you bring already this is the size is on the sales. That is why you're seeing chairs has the highest sales value. That is why this particular bar is taller than the others. Phones and then followed by chairs and then the rest. Suppose if I want to increase or reduce the size, if you reduce it, this bars are the width is reducing. If I increase it, then it will become without space. You can choose this one like this. If I reduce, this will become very thin lines. This is on the size. Now, the next one is a label. I want the measure value to be shown on the label, on the view. So what you do is drag the sales onto the label. You can 07, 27, 203, 114 and all. This is called your label. I want to bring even subcategory name also. Normally not required because you're already seeing the subcategory information here. Dimension information is already there. We don't need to show the dimension information, but still if you want to show, go ahead and bring the subcategory also onto the label. Now you can see subcategory name and also the sales value. Okay, now the data direction is different. You can change this by clicking on the label. Now, the alignment is automatic. It is showing the best way. This is the direction. I don't want that. I want in a proper direction. So now this is in this way to represent, or if you want to change the direction, you can choose 3 types of direction available. You also have the alignment, left alignment, center alignment, and right. You can keep in the center or left or the right here. For the vertical, this is in the middle, this is on the top, or this is on the bottom, your data labels. Now you are not able to see some of the data labels here. Those are all missing because space is not available. That is the reason it is hiding the rest of the data labels. If you want to see those also, simply go here, allow labels to overlap other marks, select it. Then you can see the overlapping ones. So this is not looking good, right? So what you can do is you can select this and remove the subcategory name because it's not required. It's already there, the subcategory name. Just simply go and remove it. Now you have only the values to be displayed. And then on the label, you can choose the size of the label, the text. Right now in the 9 points, you can choose 8 or you can type it 6 also, you can type it like this. The 6 points. Or if you want to increase it, the font, you can go ahead and increase it to the. So like this, you can increase or reduce. You can also color code it. Go here and click on these colors. Right now it is in the black color by default. I want to change it in the red. And then I want to make it bold, italic, and underline. Apply. So now the values are with this. I'll remove this one. And one blue. I want to make it blue color. Or you can go ahead and change more colors and choose the best colors you want to choose. I don't want to underline also. Apply. So this is the editing of the label. Now the alignment also, you can revert it back. You can choose whichever the one you want, or you can customize it. So this is the label. Tooltip, because by default it is when you go, you can see the whatever the measure and dimension you're using it, all those fields will display by default. If you don't want anything here, because 91K it is showing, I don't want to show the measure value. So go to the tooltip, remove the sum of sales. I don't want the measures to be shown. Just delete. Click OK. When you hover around, it will show only the subcategory name. If again you want it back, click on the tooltip, enter, go to the insert button, select the sum of sales, and then type it here. Before that, sales, hard code it. I'm just giving sales and then OK. Now again, your sales is back. So this is the way you can manipulate on the tooltip. For example, now we have one measure we are showing on one dimension. Suppose I want to show 2 measures on a single dimension. So this means I want to show subcategory wise sales and also profit. This is sales and this is also profit. So now you have 2 charts. One is for the sales, one is for the profit. Remember in the sheet 11, when you use only one measure, there is only one marks card is there. If you have more than one measure, automatically it will give you for each measure one marks card. Sum of sales, there is one card. Sum of profit, another marks card is there. You can choose now all these options on your own. If suppose you do changes in the all, it will be applicable for both the charts. That is, suppose if I bring the subcategory onto the color in the all, both the sales and profit is affected. Now, if I want to bring subcategory color only on the sales, bring the subcategory only onto the color sales, this sales card. So you see only the change is happening for this particular one. So this is not color is not added because your profit, you have not added any color. Now for the profit, I want to bring measure onto the profit. That is this one. And profit, I will give right now 2 colors is there. So I want to give red, green, gold. Your sales measure has a different color where I brought the dimension onto the color. So that is why every data item has a different color. Whereas for the profit, I did bring measure onto the profit, measure onto the color. So that is why it is a gradient color, 3-color gradient. So if you bring another 2 measures, another 2 marks cards will be given, like quantity if I bring. So another marks card. If I bring in the discount or orders count, then I have another marks card. So like that, how many ever you use your measures, all those measures, you will get each one measure, one marks card. So you can do all the changes, you can do customization. Now I want to show only the profit value. Suppose I don't want this one, also count of orders. For example, for the profit, I want to display the labels. So go to the profit, bring the profit onto the label. So now you can see the labels only for the profit, not for the sales. And suppose if you want the label to the sales, just go here, bring the sales onto the label. Now this is a sales value, this is a profit value. So if suppose I'm removing the sales again from the label, profit from the label, in the all, I will bring the sales onto the label. So what happens now? Both the tables will get only the sales value, even though this is a profit table, but still my data label is showing the sales value only because you have chosen that option in the all. We have the next one that is called sets. Sets are something, it is a subset of our data that meets certain conditions based on the existing dimensions. Also, sets offer the greater flexibility. We can link them to any condition. And sets appears in a separate window. Like the same way, now we have a grouping. It appears separately. The same way, sets also appears in a separate window. Below the measures, or now there is no as a sequence, you can see anywhere. And subsequently easier to locate. And they do not clutter. While we are doing the grouping, it is possible with only one dimension. But when you create a set, you can group across multiple dimensions. So this means if I want to group it, I want to group customer and the region together. That is set. Whereas for the grouping, if I'm doing a region group, it can be only region group. If I'm doing a customer group, it will be only customer group. So that's the difference. Now sets will show as in and out, the option. One is it will show as a in and out, or it can also show as a members in the set. So in means the data, the condition is part of the set, whatever you create a set. Out means any members that are not part of the set. And sets are two types of sets are there. One is called constant set. Another one is called computed sets. So constant sets are the sets that one once create, you cannot change. Even if the underlying data changes, the membership of the constant set does not change. That means, let me show that as an example. So this is, for example, constant set. Constant set means I have created name A, B, C, and their values are, for example, 5,000 sales, 10,000 sales, and 8,000 sales. So this is a customer name and then the sales value. When I create a set, if I'm creating a constant set, what happens is these names will remain as it is. So your set will never change for these customers. Even though the values gets reduced or increase, my members of the set will not change. This is called constant set. Whereas for the computed sets, it will be on a condition. So the condition is, I'm showing customers with, suppose I've identified a condition stating greater than 5K sales. Okay. Now, the next day, the sales value is dropped or increased. So when I run this again, the query, what happens is, now this time only this one will be available. And any new customers are adding, it will come here. Because your condition is greater, though the value uses or increases or whatever it is, but my members will not change. You can opt your choice as per your requirement. Either you go ahead with the constant or computed sets. Now, how do we do that? We can go to the sets, any particular dimension, go and select your set. Okay, let's do the in Power BI, sorry, Tableau. Now, so this is my table. I want to create a subset of my customers now. What subset I want to create? First, let's do the constant set. I'm creating a set. So go to the any particular dimension which you want to create. Select the drop down. Go here, create set. Now this set, here you can give, saying that a condition you can give, top you can give. The moment you give condition and top, it will become computed set. Because you are giving a value basis that you are creating a set. But instead of that, in general, I am going and selecting manually some of the customers. I want to create a set. Or go to the custom values list. One second, reset. I'll go to the custom value list and I'll give a search. Of course, all the customers will come. A customers I want to give. Now we have AA in the names of the customers that are selected. So I'll take all these 4 and then customer name customers. I'm just giving like this and create OK. Now here it can be any information, like their measures can be anything. But there is a set created. When you bring this set onto the view, it will be in and out. So in and out. How many are part of this set? How many are not part of the set? So that you can give it as a count. Give the customer ID and make this into the count of customer ID. Now, how many are there in 53? Out 9941. Why for 53? These many times these customers are repeated. So that is why it is giving 53. So go ahead and change this into the count distinct. Then it will become unique. 4 customers we have identified in the particular set. So if you want to see the names of these customers, what you can do is go here, show members in set instead of in and out. Click on the show members in set. So now the members are these 4. So here it can be anything. This month the sales is like, I'll remove the count. Now I give the sales value. I will give order date. You can see these customers. This person 2013, there is no sales. 15, no sales. There is no condition. Here you're just bringing the measures and seeing. But these people are now a separate set. I can analyze. Like, a simple way of telling is, suppose if I want to analyze a high value customers, I will create a set of my high value customers separately, and then I'll start analyzing it. What kind of products they're buying, how much profit they're giving. Is it this, the sales value is same as last month or not? Is there any dip? So those kind of analysis you can do by creating a subset of your customer. So this is a constant set. I'll show that again. So go to the customer name, click on the drop down, create a set. Now in this, you have to go to the custom value list, search A, and then click on this button, search enter. When you do that, or maybe we can say that BA in the name, if there is a BA is there, yes, these many customers names are like, there is a letter continuation, BA is there. And then you can add it as a set and you give the name of the set. This is one way of doing it. Another way of doing it is you can also bring this customer name onto the view. Take the control button and select whichever the customers you want to create a set. I'm just control button. I'm trying. Now right click and then go here, select this one, create a set. So I will say this is, okay, now let's create a high value customers. So I'll give the first sales value and then I'm sorting by highest to the lowest. Now I want to select all these customers who are more than 10,000 or 12,000. Let's take 12,000. Yeah, I've selected manually and then create a set. I'll give this set name as a high value customers. Click OK. Now there is a high value customers list is there. If you want to analyze these high value customers, you can just bring it and then see the members of the set. Now I have this. Now I want to see this customer's profit, how they're generating the profit. There is one customer who's giving negative profit, though he has the highest sales. I'll bring the sales also. He is the highest sales. His sales is coming highest from him. But end of the day, the profit is negative. So it's a loss. So like that, I can start analyzing. If suppose why this is a negative profit. So I'll double click on this one, view data, and then I'll go and see what products actually particular customer is buying and which are those negative customers. So there is one particular product which is giving negative 1811. So this is a machine subcategory and the product name is Cisco Telepresence System, a video conferencing unit. So that is the highest sales, 22K he brought, but we gave so much of discount. We gave 50% discount. That is the reason it is in negative profit. So like that, they can do analysis by taking a subset of your data high value customers and how do I improve the profit of this customer? Or go and see this Ken is giving only 807 profit. How do we improve it? So these kind of business decisions they can take. So create a set. This is the set and give a name of your set. When I click on the create set, you can give whatever the name you want. Okay, once it is created, then what you do is bring that. Now you got high value customers, bring it onto the view. High value customers. Here you will get in and out option first. So select the show members in set. Okay, so once you select, now you bring whatever the measures you want to display. Sales, profit. So how to use this one, I will show now. Instead of members, you can also show it in this way. Bring the customer name. Now you bring the sales value. I'll just give the chart. What I'm going to do is here, what I'm doing is I'm bringing the high value customers onto the view. When I drag and drop, what happened here? It is on the color. So let's give the proper colors. In, I'm giving red color. Out, I'm giving yellow. Now you can see in part of set, who are those customers. If you scroll like this, you can see those customers. So I'll just sort it out. So these are all in customers and these are all out customers. So members, you can use it, or even if you want to show in and out option, you can show this way. I just drag the high value customers onto the view and then it goes onto the color. Give the prominent color so that it will show that. In means whatever the data you have taken out, that is part of the set. Out means those customers are not part of that set. I'm just adding in one more thing, that is I'm giving a year now. Suppose if I want to understand yearly, order date onto the next two. What I've done is I'll give year here, filter. This is the way you can do the see the changes now. Because here we gave only with the names. As an overall sales value, they are the highest. But if you see individual years, 2012, only here see, there is one more customer is highest sales. But though he has the highest sales, he is not actually colored because this is a constant set. We have identified manually the customers. That is why it's a constant set. So where are those customers? You have one customer here. You have one customer here. here one, like that. In 2013, so this is different. Whoever actually we selected as a high value customers, they are not there in the 2013 as a high value. But still, this is not changing. The reason is we gave that as a customer name only, manual set. The 2014 is different. Here it is, fifth customer. 2015, only 3 are top. When you take overall, they are here on. This is the constant set. While the same thing we can do as a computed set. How do we do? Go to the customer name. Go to the set again. Click on the set, create set. Here you go to the top condition. Or go to the condition by field. You say that by sales, sum should be greater than, you're saying customers who are greater than 10,000. You want to create a set. Okay. So this is customers greater than 10K sales. Click OK. So this is a formula based. Now you bring here your customers. Again, customer name, sales. And then you bring the customer greater than 10K. So all these customers are part of set. These customers are not part of set. Instead of bringing here in and out, you bring it onto the color. You can see the color. Correct? So far this is work. Now next one is if I add in this a date, order date. Now the names are changing. The color is also changing. Let me give the light color of out. Or something like green. See, these names will start actually dynamically will start change. For 2012, who are my customers? Okay, 1 second. 2013. No, just a moment. All, we gave it on the all. So that is the reason it is not changing, not this one. Sorry. Where is it? Customers. Edit filter. Okay, not here. Just a moment. Top by field. Top 10. I'm giving top 10 by sales. Apply. So these are the top 10 customers. Right? When you change the sales value for these customers, then automatically it will start changing. Is the year is added? No, here is not added. Okay. This is not relevant. So now these customers, if you change tomorrow, the total sales value for Sean Miller right now 25K. If this reduces to 20K and other customers who are in the top position with the 25K and above, they will be on the top. So this is a dynamic customers. That is called your computed sets. So what I have done is I went to the customer name. I have created a set which is top 10 customers by field. That is a sum. Sum. Always this top 10 will change according to the sales value. Whenever the sales value is changing for that customer, those top 10 customers will keep on changing. Okay. So now first you all create the top 10. It has a top 10 customers. Name your set as a top 10 customers by field top 10 sales value. I'm creating one more set, top 20 customers. Go here by field top 20. Click OK. Now we have another one that is top 20 by customers, top 20 customers by sales. This is the 10 customers view. You can bring even 20 also. You will see another one that is again in here. Okay, so just remove now 10. Now you can see top 20 customers. Are we good? Now, how do I use this in the filters? So this is on the view we created. If I want to use this as a filter, what you can do is remove from here. Sometimes I want to show only the customers who are part of the set. Sometimes I want to show who are not part of the set. So what you can do is bring the top 10 customers by sales onto the filter. Okay, and then click on the show filter. Show set or show filter you can choose. As of now, I'm showing as a show filter. It will give the names of those people. Or you show it as a show set. You can get top 10 and rest of the ones. Now what we can do is we can go here instead of members in the set, select the in and out of set. In and out. Now you remove this one, hide card. Now go ahead and show the filter. Here in customers or out customers who are not part of the set, who are part of the set. You can enable this one as a filter for the end user. So if they want to see all, they can see everything. And then now select only in customers. Out, only the customers who are not part of set. These are there. So total 10 customers are part of set. That is why you get 10 rows by one column, these 10 customers. Out customers, which are not part of the set, they are 783 out of 793. 783 are not part of the set. So this also you can have like multiple ways of showing your sets data. You can use it as a filter, you can show it on the columns, or you can show it on the direct view, or you can also color it.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Or if you want to do analysis only on this, you can do the analysis also. Constant sets, that is, for example, I want to identify the anomalies from my data and I want to see them as a separate set. So I'm creating sales, profit, and then I bring the customer name. Okay, this visual I will teach later, but just for your understanding, I'm showing this one. So now what this data is representing is your data, your customer's distribution basis on the sales and profit. I want to identify the anomalies. So I'm seeing, so these are the customers who are a different behavior. I want to create a set. You can directly on the chart, select like this and make it as a create a set. So I will say maybe high profitable and high sales and profitable customers. So these people will never change. The reason is you're manually creating it. This is called constant set. Though if suppose tomorrow this value will become less, still from this in the set, this person name will never change. So that is the constant set. Now we have a high sales and profitable customers. Now bring it onto the color. So you can see in and out 2 different colors. So all the green are your customers who are not part of the set. The red are which are part of the set. So manually, suppose if I want to create another set, only these 2 customers, I can select like this and create a set. Create set. These 2 will be a new set. So like that, you can create on the screen, on the visualization also. On any chart, you can do that. So I just, I'm not given any condition. I've selected only this customers because this is distributed as per the customer. I've selected like this and I gave right click, high value, high profitable, because I know that this is sales is here. This is your axis, right? Profit is also positive profit, high profit. Yeah, so that is the reason I gave it as high sales and high profitable. If at all I want to give the condition, then I will give like this. What I'll give high value. This is a constant. If I want to make it as a dynamic set, then I'll give the condition. Here I'll give by formula. Always sum of sales should be greater than 10,000 and profit should be greater than 2,000. So this is the condition you can give. So this is again dynamic set. So it's also called computed set. As per the values, the members will start changing. So I'll say that high value and high profitable, high sales and profitable, dynamic set. So now if you bring it onto the view, what happens is if tomorrow the value is changing for these guys, Like today, profit is 2000. Tomorrow, if the profit becomes negative, then the Christopher will not be part of this set. But whereas here, I have done manually, even though for Tamara Chand, for example, tomorrow profit is reduced to 1000, but still he will be there. This is called manual set, which is also called constant. This is called computed set because you gave the formula. So that's about the sets. So with this, we have learned the sets. You can see that you can refer this one. Constant sets, computed sets, and the combined sets. Okay. Now we also have the next one that is called bins. So bins are something which is useful to organize the values of measures into the bins. Sometimes what happens, like, I need to give the distribution frequency or a class distribution I want to give. So you can use the bins. Bins can be created using the histogram also. So that is, go here. Suppose there is a measure is there. I want to create a quantity bins, or age is there. I want to create age bins. Age is a measure, right? So 1, 2, 3, 4, like that, the numbers are there. I want to create 1 to 15 years of age. How many customers are there? 16 to 30, 31 to 40, like that. I want to create the bins. So that you can use the bin option. Here, quantity also. I want to create the quantity. How many customers are buying? 1 to 2 orders, or 2 to 4 orders, 4 to 6 orders. I can create the bins. So how do we do the bins? Bins are only on the measures, while sets and the groups are on the dimensions. Bins will work on the measures. There are two ways of creating the bins. One, you can go to the show me directly. So this is the option called histogram. You can just simply bring one particular measure onto the view and select this option. So there is a bin created. So that bin you can see is quantity bin. You can see here. What I've done is I just brought a measure onto the view. Okay. So this is the measure, and then this is highlighted. So I'll go and select a histogram. So system by default, it will create the best possible bins for the quantity. Now this is the quantity bin. If you want to understand how this quantity bin is created, just go here. There is a quantity bin created here. Click on this drop down, edit. Now you can see. Okay, so it has taken the count of quantity. Maximum is 14 orders and minimum is 1. Now the size of each bin, the frequency distribution, it is suggesting 1.77. You can choose your own. I want to give 2 as my bin size. So it should show 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. So I'll choose 2 and click OK. Now the bin size is separated, 0 to 2, 2 to 4, 4 to 6, 6 to 8, and so on. So what you can do is you can bring the quantity count, the count of quantity onto the label. So 899 orders are 0 to 2 times ordered. 4,811 orders are 2 to 4 times ordered. So that is what actually it shows. You can even change this into the count distinct also. See, 1 order, 2 order, 2 orders, like that, count distinct. But count distinct should not work. It's not the way to represent it. So just go with the count. So this is one way of doing it. While you are in doubt, directly go ahead and choose the histogram. Automatically, it will give you the best option. Now, how do I do manually the bins? I'm clearing this sheet. Also, I'm going to the quantity bin here, already generated one, delete. Now I'll create it on my own. So how do I do that? Go to the quantity, click on the drop down, create bins. So you have to go to the measure, select the drop down, choose the option called create and select the bins. Here it will ask you. So the name is quantity bin. I want to give 1.5 instead of 1.77. Tableau suggested 1.77, but I want to give 1.5. Now click OK. So there is a quantity bin generated. This one you bring it onto the view. Quantity bin now 0 to 0, 1.5, 1.5 to 3, 3 to 4.5, 4.5 to 6, like that. Now this is the one. Now you give the count of customers. In this quantity, I want to know the count of customers. Bring the customer name onto the label and convert this into the measure count. See, 899, 2402, 3600. First, you bring the customer name onto the label. Bins, when you convert, if you remember, there are two types of fields. One is a discrete and another one is a continuous. Sometimes when you're working on your reports, we need to convert the measure into the discrete and discrete into the measure. So this is one of the situation. Now, earlier one, while we are representing on the visualization, it was showing in the green color. So that is already the visual developed. So though it is showing as a measure, but still it is not a continuous value. Okay. It's a bin. So this is the one. Let me do it again here. So here, though this is showing as a continuous, but this is working like a bin. That is why for the visualization, it will show as a green. While you create manually, this is what the exact the quantity bin. And then you can convert into the swap rows to the column and select this chart. If you, because it is a discrete, it is showing, if you make it continuous, just go here and make continuous. Now you will not see any gap. So both the ways you can use it. If you are using it as a discrete value, it will show separately. 0 to 1.5, 1.5 to 3, and so on. If you show this as a continuous value, it will be continuous. Either ways you can use. Continuous is always aggregation. So you can perform measures. Whereas a dimension, you treat that as a each value as an individual value. You cannot do the aggregations there. Okay. So with this, what we have done is we have completed basically the second part, that is the second module. So we learned the filters, we understood the dates, we understood the dimensions and measures, we learned interactive filters, marks card we learned, hierarchies, folders, sorting done, also order of operations we learned. Highlighting we have not done, I'll show highlighting. Sorting is done, grouping is completed, sets, both constant sets and the computed sets, and the bins. Now the next topic is the parameters, but yes, parameters we will not do right away. What we will do is today, we will get into the calculations, the third module. Halfway through calculations, we'll go back to the parameters, because even in the parameters, we need to use the calculations. So that is the reason. So I'm opening the module 3 now. So we will move to the calculations. So now in the calculations, what we are going to do is we will learn various types of calculations in Tableau. One is predefined calculations, quick table calculations, LODs, which are also called a level of detail expressions, and the calculation syntax. We write it on our own. So some of them are already predefined, some of them are quick table calculations, and rest all we can also write the calculations in the syntax. And LODs, there are three types of LODs: fixed LOD, include LOD, and exclude LOD. So this is a different level of showing the information onto the view. After this calculation syntax, we'll move back to the parameters and we'll learn the parameters. Okay. So let's go back to our calculations. Now calculations, when you bring some information like subcategory is there and the sales value, correct? So what is happening here? It is aggregating. Your data is a row level data. So every transaction, there is an individual row. So when you bring in a dimension, it is summarizing it. So this means by default, Tableau does the addition. So what is my accessories total, appliances total? Suppose another one, if you show the region wise, now your sales is aggregated at the region level. So if you go here and you do the aggregation, you bring the segment, then the aggregation is at the segment level. So by default, it is an aggregation. If you don't want the aggregation, sometimes if you don't need the aggregation, then you'll go to the analysis, deselect it. So every individual row sales value will be displayed like this. Maybe you can see better way. All the 9,994 marks are updated here like this. Now I'm going back and selecting aggregate measures. So now this is aggregated as per the subcategory level. Now I want it total. I know this is individual subcategory wise sales is aggregated. If I want the total, that's the where we have analysis. Analysis is for your calculations. Go to analysis, click on the totals. In the totals, select this is a column, right? Column grand total. Now you have a column grand total. The total sales value is 2.2 million. Okay. Now I want the row grand total. So if you bring in profit. So now the grand total, column grand total is coming. Total profit is 286K. Sales is 2.2 million. Now I want the row grand total. Go to the analysis, click on the totals, show row grand totals. But now row grand totals is not working. Okay, I'll give another example. Suppose, for example, here it is working, right? So when you're actually choosing, these two are different. Sales is different, profit is different. So it's not correct to add both. Right? So that is the reason. Logically, it is not correct. So that is why it is not giving you the totals in the previous sheet, row totals. So the difference between here, why the row totals is not coming is these are two different measures. They are not same measure. Whereas in this case, only one single measure, that is the sales, but you are giving just a breakup of yearly information. So that is the reason the row grand total is also working. But again, in Excel, it will work because Excel, you will write a formula, right? You'll just go here and in the Excel, if I want to add these two, suppose assuming that this is profit, this is sales. If you want to add it, you just simply go here and give sum of these two. It doesn't look for the logic because it's not checking here. Just go ahead, simply you are giving the formula you can do. The same thing is also possible in Tableau. You can write a manual calculation wherein you can write sum of sales plus sum of profit. At that time, you can get the row grand totals. At that time, you don't need to bring this as a grand total. You'll bring the new column next to that. So that is the way. Otherwise, logically, this is not correct by giving the row grand totals. Now, I'll go to analysis. I have options called subtotals also there. Add all subtotals. So when I have a hierarchy, I can show the subtotal. So how do we create the hierarchy? Because we already done in our data, right? So we have created a hierarchy where you can use that hierarchy to show that. So because I don't have the hierarchy, maybe I want to. Manually also you can do, don't worry. If you don't have the hierarchy here, just you do one thing. Go, bring the category and then subcategory. So there is a hierarchy now. Now it's sales value. If you all are ready like this, then what we will do is go to analysis, click on the totals. Now add all subtotals is enabled for all of you. Now click add all subtotals. So this is a furniture total 742K, office supplies total 719K, technology 836K. Go to analysis again, totals, show column grand totals. Now we have a column grand total also. So now bring another measure. See, for example, sales is there. You gave the analysis sales. and gave the totals, add all subtotals, and show column grand totals. Now what we do is, instead of bringing it onto the text, drag the profit and leave it here. At that time, you don't need to do these two steps. Directly, you can leave it on this. Now bring the quantity also like this and drag and drop. Now the quantity is also there. Now the discount, I'm leaving it. Okay, so all of you see the discount is here, right? This discount is not actually giving the right value because discount cannot be an aggregated sum. Profit and then discount. So if you observe, discount can never be a sum. It should be the average. While you're aggregating it, it has to go as an average discount. So we'll park this one aside. How to change this into the average? Let's see. Now, when we're doing the analysis, go here. You have an options called row totals to left and show columns to top. What happens by default? Always it is a bottom, always your totals. If you want to take it to the top, you can choose the totals, column totals to top. So first it will give the totals and then the breakup it will give. Okay. The same way, if you want the row totals to the left, by default it is right. Go analysis, show row totals to left. So first the total will show and then the breakup of that particular dimension, each it will give the individual ones. You can choose like a different way of representing your data. Now going back to this one, you have option called analysis in the totals. For the subtotals, by default it is sum, that is an automatic sum. I want to change all the values into average. Click on the average. Now averages are done, but average is done for what? Only the subtotals, because this average is only for subtotal. Individual level values are not changing, these level. Only the totals are averaged out. Earlier it was sum, I'm repeating. See, earlier this was sum, 145K, 122K, 948, 369. When I gave the average, now these are all averages. So what it does, it will take all the values and what is average. All the values and what is average. This is for only totals. Now go here, you have 4 options. One is sum, one is average, another one is minimum and the maximum. When you give the minimum value, in this section, it will go and see what is the minimum value in this. For example, in the quantity, furniture segment, one second. Let me move this totals, it's so confusing. Show column totals to the top. I'll remove it. Okay. Now, in the furniture segment, what is my minimum value? 868K. That is what it is showing. In sales, the minimum value is 91K. Furniture segment. Profit is negative 17K. And the discount is 48. That's what it will show minimum value. If you want max values to be shown, go to totals. Totals all using maximum. Now it will go and check what is the maximum value for this one, 26K. That is what it is showing. For quantity, it is 35. And the sales is 328K. That's what it is representing. Now the next one is this. This is the total level we have done. Now I want even this individual level also. That is bookcases. Right now this is sum. What if I want average? What if I want maximum, minimum? Now I'm removing the profit quantity. Now this is the sales only. There is a next option called whenever you bring any value, either in the columns or in the text anywhere. If you want to change measures, in the measure, you have options called, click on the drop down, even here also, suppose if it is here, I'm removing the category, a subcategory. If I want to, right now, this is a sales sum, correct? If I want to change this into the average, Then go ahead and change into average. So what are the things you can do here? I'll keep it on the label so that we can see the numbers. What all we can do? We can do average. Now everything is average. We can see median values. What are the median values? For accessories, it will take all the accessories values and it will give the median value. Same thing appliances, copiers. What is the count? If you want to see the count, you can see the count also. Or count distinct, unique values. These are all count distinct. What is minimum value? This is a minimum value. Max. This is the max. So all these values are happening on the sales. In the sales, what is the maximum value for accessories? If you want to test it out, what you can do is go view data. So max sales is showing 3347, right? Go to full data. Here you can go and see in the accessories segment, sales. What is the max value? 3347. That is what it is showing. 3347. And there is one sale happened at the 3347. So that is what the max value it is showing. Appliances 264. So now if I want something else, that is percentile. What is my top 5 percentile in this? What is my percentile, 10 percentile or 95 percentile, whatever it is. You can see the values. Or if you want to know the standard deviation, these are standard deviation values. Standard deviation population, variance and variance population. So these are the options available for any measure you are bringing onto the view. Right? Now, I want to bring the discount now to convert that into average. So drag and drop discount. Now go to the sum of discount here. Convert this into the average. Now the discount is averaged out. Right now it is showing zeros. What you do is go to the average discount again, format. When you click on the format, it is giving you the numbers. Select it. That is the percentage you need to select. Now you got your percentage. I'll repeat again. What I've done is first, I'm bringing the subcategory and the discount value. So by default, it is a sum. That is why it is doing sum discount. But correct way of doing is the average. Now it is averaged out. I want to show it in the percentages. For that, what you have to do is go to the average discount again, drop down, click on the format button. It will open. In the default section, go to the numbers, select the percentage. Now the percentage is done. Okay, I'll tell you the step by step. You all brought the discount here. Okay, now go to the sum of discount here. In this, select the average. So you will see the values like this. To make it into the percentage, go again, average discount drop down. Now click on the format. This one will open. You have to be in the pane. Okay. Here, you see font alignment numbers. Go to the numbers. Click on the drop down here, percentage. You can use your decimal places. If you want to increase the decimal places, or if you want to reduce, if you don't want decimal places, round it off to 0. Now discount, we have done the setting. Let's bring the sales also. Now sales is in the number, right? I know that this sales is because this is a US data. It has to be in the USD. How do I bring the currency onto this one? Well, let's bring profit also and then the quantity too. So now you brought all the measures. There is a sales, there is a profit, there is a quantity. Quantity is okay because it has to be in the number. Profit and sales are the currencies. I want to change the currency. I want to give the currency for this one. So what you can do is go to the sales here, drop down. Click on the format. Okay, when you go to the sales and drop down, click on the format. So there is a pane. It shows the numbers. Here, click on this. The first step is whichever the country you're based out of, automatically when you select currency standard, it will give that particular country currency. So what it is giving, I'm based out of India, so that is why it is giving rupee. If you are in US, you can see the dollar symbol. Now, how do I convert? I want to convert this into the USD. So go here. First, select your currency. Out from English India, select English US. So go here. All the country currencies are available. Select the English United States. This is only for people who are based out of India. If you are in US, that's fine. It is working. Select the English United States. Now it is in the dollar. Now go to the currency custom. This is individual units. Sometimes I want to convert this into thousands, millions, billions like that. So what you do is now go to currency custom. You can choose the decimals. Right now, 2 decimals. I don't want decimals at all. So I'll round it off. Now display units is none. I want to show in thousands. Now this is converted into thousands. Or if I want to show in the millions, I can show in the million with the decimals. Because everything shows as 0. If I'm choosing the billion, then I'll go with the decimals. Or if you want to show in the billions, you can and so on. So right now I'll go with the thousands. So now this is 1000 values and without the decimals.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Now, if I want a different currency, Amazing Mart is there. One country it is pounds, another country it is euros and all. So you can go currency custom, currency standard. First is currency standard you need to select. Go here, English United Kingdom. Now it is changed to pounds. And then go to the currency custom, do your changes. You put in the thousands and remove the decimal places. Now this is in the pounds. While you're doing it, sometimes there are negative values. For example, profit has a negative value, right? Okay, so let me change this into the first English United States. Now it's in the dollars, currency custom. I'm changing this into thousands and then no decimals or 1 decimal I'm giving. Okay, so we are good sales we have done. For profit is there. I want to change the profit also into the currency. Now click on the sum of profit. Again, format. Now go to the profit format. Click on the numbers. Here, currency standard. Select this. Again, you choose your United States. Then go to the currency custom. Here you have an option. What is that option? For the negative values, sometimes I want to choose the negative values within brackets or without brackets. Whichever the format you want to choose, you can choose. Suppose this is by default, it is giving with the brackets. Wherever the negative values are there, it will be in the brackets. I don't want to show that way. I want to show negative. So now this is symbol it will give. Negative symbol. This is one format. You have another format, this one. Third format is after the value negative symbol. Or after the dollar and then negative symbol. So like that you have formats, 4 formats available you can choose. Automatic, this is the one. Or I'll choose this one. So that now click OK. So we have done now properly. Sales, we kept it in the currency. Profit also in the currency. Quantity is in numbers because these are all units. Discount is in average. Okay, so the next one is, these are all we've seen, like, what we can do with predefined calculations. We have another option called quick table calculations. So some of the calculations, like I want to do the percent of total, running total, these kind of things, if we want to do, we can use the quick table calculations, which is available already predefined. So go to the new sheet. I bring the subcategory again. Okay, sales value. Now this is the sum, but I want, if suppose a running total I want to create. What is a running total? It will add the previous value and it will give the cumulative. Again, it will add to the cumulative to the previous value. It will give the cumulative. So that we can go ahead and do by clicking on the sum of sales drop down. Go to the quick table calculations. Okay. Here in the quick table calculations, we have options called running total, difference, percent of total, ranking, percentile, moving average, YTD total, CGR, YOY, and YTD growth. So these are all predefined calculations available. We can use this. Now I want to select running total. Now what it is doing, first it will take accessories, actual value it will give. Next appliances, it will see what is the total value. That appliances will be added to the accessories and this will become your running total. If you want to test it, what you can do is, again bring the sales onto the view. Now you can see 167, 167. Okay. 167 plus 107 is 274. For the art, 167 plus 107 plus 27 is 302. Like that, it will add running total and finally your 2.2 million is here. So when do we use the running total? When you have your year is there. If you want to see today, this month is how much. If I add the next month, if I want to know what is my cumulative total, you can use the running total. This month plus previous month, what is the total value? Okay. So this is called running total. Now the next option, now go to sum of sales again. Whatever the changes you need to do, every time you bring the sales, you bring the measure there and then do the changes. Now go to sum of sales. Here now next step is I want to do the difference. So what is the difference? How does it work? It will check with the previous value and what is the difference. Now bring the sales again onto the view. See, for appliances, it is 107, but whereas accessories, it is 167. So 107 minus 167, that is negative 59. Now for the art, what it will do, it will check the previous value. Art is 27, appliances is 107. So the difference between these two is negative 80. For the difference, it is always with the previous value. Whereas for the running total, it will do the running total of all your previous values. But for the difference, it is always with your previous value. Now the next one, we have the quick table calculation, which is called percent of total. Let's do with the percent of total. What is percent of total? It will give you the contribution of each to your total sales value. So that you go ahead and click the percent of total. Now to the total sales value, accessories is contributing 7.2%. Appliances is contributing 4.68. Art is 1.18. So when you add all these things, it will become 100%. So this is the percent of total. If you want to test whether it is total 100% or not, just simply go to the analysis totals, show column grand totals. Now you can see 100%. Now there is a percent difference also there. So this is the value difference. If we want to see the percentage difference, again bring the sales here. Okay, go to sum of sales on this drop down. Quick table calculation, percentage difference. It will give the value difference in the percentage form. So whatever this negative 59K, if you put it in the percentages, it is negative 35%. 80K is negative 74%. Positive 176K is 650% positive. So like that, you can see the difference in percentage. Okay. These are all predefined calculations. So there is no as such error will go. When you write your calculations on your own syntaxes, at that time we may get doubts like, whether you have given a right formula or not. So that time, yes, we can do some of the checks like going back and doing it manually. But these predefined calculations are properly done. Now, after this, we also have another calculation called a ranking is available. Most of the time we create the cards, report cards, like, who's performing well and all those things, those ranking you want to give for the sales team, for example. So you can use the ranking by going to the sales. This one already selected. Go to the sum of sales. Quick table calculation rank. This ranking is happening on the sales value. Now you all can see the sales value. Base is the sales value. Phone segment has the highest sales value. You want to test it, just bring the sales onto the view again and sort by sales. Sorry, this one you can select and sort it. Go to the measure names, click on the sort. Now you have so many others, so go by field. Oh, sorry, why this has come here. Sorting has to be done. Yes, this is the way. Now you see, the sales is 330K, which is the highest of phone segment. That is why the rank is 1. Or you can do with the rank also, but just I wanted to show whether it is correct or not, the ranking. So you can see this. Now the running total is changed, right? Earlier, phones was not in the top segment. Now even the running total also changed accordingly. So this is a ranking. Now the next one we have percentile is there. Moving average is there. Before getting into that, suppose if we have subcategory sales, right? When we give the ranking, also another one, that is region. So when I'm giving the quick table calculation rank, for example. So what is the mode right now happening? 1, 2, 3, 4 for every row it is giving. So this is called compute using table across. So it is doing the calculation this way. Now I want compute using table down. Now it will give 1, 2, 3, 4, 5, 6, 7, whatever it is. For every region, it is giving now table down. You have another option called table across and then down. First, it will calculate this and then down it will give. So that is the reason your chairs has the highest. If you want to test it, just bring the sales again here. Okay. So now the first one, overall on everything, highest is 101. So that is where rank 1. So next one is the 2. After that 101, it is 100,615. So that is why this is second position. So like that, what it will do, the calculation, it will go and check table across and then down. If you select table down, then across, it will calculate this way and then this way. Now, we also have the pane across. Pane is you have the same. Everything is rank 1. Pane across and then down. You will get the proper 1 to 17. So compute using again pane down then across. That also works the same way. Now we have cell wise, specific cell wise. Every cell it takes. So for every cell it is rank 1 only. Or if you go ahead with the region, then the region level. So every region, 1, 2, 3, 4 regions are there. That is why 4 rankings. So you always get 1, 2, 3, 4 like that. Or compute using by subcategory. So it will take subcategory level and it will assign that. Now 1, 2, 3, 4 as it is. Now the question is, how do we rank sort it? When you have region and subcategory this way, when you sort by sales. Okay. So because overall chairs is giving you 85. Sorry, overall phones has the highest sales value. When you go here in the subcategory, your sales as an overall, phones has the 330K highest. So that is why for every region, though in this region it is in the second position, in this region it is in the first position, in this region first position, this region second position. But when you take overall, the position is first. That is why your ranking will come. For every region, it cannot sort by. It can take only the subcategory level. So now when you have to do this one, what we have to do is we have to write a separate calculation a manual calculation, which I will show it later while we are doing the calculation field. Okay. So now this dense and unique. Okay. So suppose you have a repeated numbers. When the dense and unique we use it, if you have same ranking is given to two numbers which has the same values, at that time, how do you choose it? So that is what your options here. So what happens is these things will work more when you have multiple dimensions you are using it. Otherwise, if you have one or two dimensions, it shows the same information. You keep on adding multiple dimensions like this. Subcategory, give the category and also the region. Now you do the calculations. If you give the ranking, then you can start checking this one. Table down. This is very simple, table down, table across. Table across and then down. First it will go as per the table. Furniture chairs it will select. Furniture tables it will select. Furniture bookcases it will see each and everything and then it will give. Table down then across. It will select first down and then across as per the sales value. Pane down. Pane down is also similar to your table because here it is considering pane and table are both are you're picking up from here only. So pane is this one, these values. And then a pane across then down. So what it is doing, pane across, furniture in the segment, these are all not there. So it shows blank. So it is completed here. The same way office supplies. This office supplies, these are not part of office supplies. Blank. This is, I'm just showing you the concept. These are all options available. While we are running the calculations at that time, these are all important. We'll continue practicing it. But understand table down and table across then down and table down then across. These four are majorly important. So now that is about the ranking. We also have YTD totals. These things are disabled right now. These two we'll discuss later. These are all disabled. YTD total, compound growth rate, year-over-year growth, YTD growth. The reason is to do this calculations, you need a date value. Then only this will get activated. Okay. Now let's go to the next sheet. You bring the order date and then bring the sales, for example. So year-wise, this is a sales value. Now go here. Now compound growth rate is activated, year-over-year growth. YTD total is not activated because your data is not expanded to month level or quarter level. That is why YTD total is not showing. We'll get into that later. So you have now two options available. CGR you can calculate year-over-year growth. So select year-over-year growth. The growth will be in the percentages. Bring the sales again and see. How much between 484 and 470 in 2012? The sales value was 484. In 13, the sales value is 470. Now the difference is negative 2.83. So that is what the percentage difference. So you have taken a formula that is year-over-year growth. So there is a negative 2.8% down compared to the 2012. Whereas in the 14, it has checked with the 13 and it is showing what is the growth rate. 29.3% growth positive. For the 15, it is 20.62. So the formula is, underlying formula is the difference divided by whatever the previous year. That is the growth rate. Now the next one, we have the CGR is there, compound growth rate. So this is a compound growth rate formula. Now how do I activate the YTD total? Just expand this one. Now quarter is there. Bring the sales value again. You can see the YTD total now. Now click on the YTD total. And then bring the sales again. So YTD total, how it is calculating? 74. This is like a running total it will calculate. Q1 is 74K. Q2 is 86K. So these two put together by Q2, the total value is 160K. So which is a running total, YTD total. Q3, these three put together, which is 304. And by the time Q4 calculation, it is all together 484. Now coming to the next year, it will not add the previous year. It will start fresh the next year because this is called YTD total. So every year it will do the Y year to the date. Now this is 2013, 2013 Q1, Q2, Q3, Q4. The same way for 14 and then the 15. Now you can expand more. If you give the month, then your YTD total will be for the months. 13K, 13K plus 48, which is 18K. 13 plus 4 plus 55, 74. Now, till 1 year completes, it will do the YTD total because it is a YTD total. The same way you can expand more, you can do even the day level also running total. That is your YTD total. If you don't want to see the day, you can collapse month. You want to see only at the quarter level, you can click on the quarter. I have done here edit table calculations. I have chosen the percentage difference from. So how this happened? This is on your year over year difference. That is your year over year growth. How does the year over year growth calculates? It calculates the percentage difference. Now, we have done the table calculations, CGR, year over year, YTD growth and YTD total. Tomorrow, what we will do is when we learn the calculation syntax, at that time, I will show you how to compare YTD versus previous year YTD, MTD versus previous year MTD. So those are all the things which we need to write manually. Moving average and the percentile, because moving average is the Windows average Excel calculation formula. We'll come back to that later. Now, these are all already available, predefined, quick table calculations. We are using it. We are not writing anything, correct? Now, what if I want to start writing my own calculations? And one thing you have to observe, whatever you're doing it, this is only to that visualization. Whatever you do here, quick table calculations, totals, and aggregations, that is happening only at this sheet level. But while you write the calculation syntax manually, that is available for all the sheets in the workbook. You can use it on any worksheet. And also it will create a new column here. When you create a calculation field, it will create a new column. So this is only the visualization view. That will be part of your query also. So how do we write? There are three ways of doing, sorry, not the three ways. You can identify, you can select it from three different ways. You can go to analysis, click on the create calculation field, or go to the drop down, small drop down here. You can create calculation field, or go to any measure, click on the drop down, create calculation field. You can choose it. Easiest way is go to analysis, select the create calculation field. Now this is the box it will open, all of you. So this space is for us to write the calculation formulas. Go to analysis, select the create calculated field. Now this one, a small arrow you're all seeing here. This arrow is for the syntax. Just open this arrow. You can see the formulas. Number, string, date, type conversion, logical, aggregate formulas, user formulas, table calculations, spatials. So all the formulas are available here. If you know the formula, just go ahead and write it. If you are in doubt, suppose for example, I want to write a number formula. ABS, ACOS, cost. All these formulas are there here. You can click on this. You can see the example also given. What does this will do and what is the example? For example, if I'm going ahead and clicking on the logical formulas and case, if condition, if else, when, all are there. Aggregations. So you have done right now average you have done. That is at the visualization level. If you want here, you can create average. For example, average of discount I want to create. Select average, give it discount. Click OK. There is a new calculation field is created. Now this one I can use it on any of the sheets which I want to use here. So there is an average discount. Go to subcategory, bring the average discount. See, now it is aggregated average discount. Go here, convert this into the percentage. Now this is properly average. So this will be available and it will be also available in the data source. When you click on the data source, it has created a new column called average discount here. So this is the one. When you write in the calculation field, you always will get a new column. See, this is a new column. Now, again, go to analysis, create calculation field. We also have user names, like full name. If you give, your computer name will display and all these things. And you have table calculations, first index. I told you index. You can choose index for ranking. You want to do it at the every region subcategory level. If you want to give, you can choose the index ranking. Rank dense. So whatever the quick table calculation, those things also available. You can create a separate calculation field if you want. You can use already predefined, or if you want to write it on your own, you can choose. And spatial, this is for the geography. We have string functions. You can contains, ends with find nth value, left, length, trim, L trim, right trim, min. There are regular expressions also there. So we can use these things. Okay, so thanks everyone.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below.